All right, guys, today we're doing something really special. We're doing the New York State Algebra 1 Regents from January 2019 that just occurred a couple days ago. My name is JuanTutors. My goal is to get you the highest grade on the ACT so that you can get into the college of your choice and the career you deserve. Now, you might be wondering, this is the Algebra 1 Regents from New York State. Why are we doing this for the ACT? Well, one, if you're from New York, you should definitely be watching this. But if you're not from New York, the thing is that New York is one of the biggest states in the country, so the ACT builds its curriculum largely on what the bigger states do: Texas, Florida, California, and of course New York. So a lot of what's on the ACT actually comes from New York. And as a bonus for you guys watching this video, in the description below, I have some really exciting content. I have 3 practice tests for the New York State Algebra 1 Regents, a baseline, a midterm, and a final with a student-ready solution set, so that if you do the testing, you want to grade it, you can actually grade it on your own. And also it gives you resources where to go for each individual problem if you have trouble on any individual problem. So this is definitely for you, and it's a super low price. And I'm really excited about something else. Ready? This t-shirt. I've never sold a t-shirt that got so much traction compared to this t-shirt. Everyone who sees this shirt loves it. You see, it's not just a pi, it's actually the digits of pi. 3.14159. Well, the first 500 digits of pi are on this t-shirt, and you can get it for a super low price. The link is also in the description below. If you bought that, you'd be supporting my site. I use that stuff to get better technology and make better videos. If you want to support me, definitely go get that t-shirt. You know, Pi Day is coming up March 14th. It's almost here, so that's another good reason. And if you want to support me by supporting yourself, definitely get the Algebra 1 baseline, the midterm, and the final, and there might be a little surprise there for you too. Let's get started. My name, JuanTutors. School name, well, JuanTutors. And .com or YouTube. Problem 1, they love asking questions about scatterplots, so pay attention. The scatterplot below shows the relationship between the number of members in a family and the amount of a family's weekly grocery bill. So when I'm looking at the chart, I see a general upward trend. It looks kind of like this. Good. I see the numbers: grocery bill in dollars, 100 to 600, number of family members, 1 through 9. I always read the labels and I do a quick cursory glance at the graph. I know I'm gonna have to go back to look at the graph again. That's why I do a quick glance. So then I go on with the rest of the problem. The most appropriate prediction of the grocery bill for a family that consists of 6 members is $100, $300, $400, or $500. So let's look at this problem. It's asking for the most appropriate prediction for the grocery bill of a family that consists of 6 members. So here's the grocery bill and here's the number of family members. I see that these answers are actually quite far away from each other. When they ask you multiple choice questions on quick scatter plot problems, the numbers have to be far apart, because you see that line that I made, that general trend line, it kind of cuts through the middle of the data. Half the points approximately are on top, half are below. In fact, I could even improve it a little bit, but the truth is that there's so much variation in your estimate of your trend line that they can't put the numbers close to each other. There's only going to be one answer that makes sense in the multiple choice. So we go to 6 family members. We go up to that trend line that we drew. This is how to do every trend line problem. Draw a really quick trend line. So we go up to that quick trend line that we drew. There's the point. And then we go, so at 6 family members, and then we go to the right to figure out how much that grocery bill might have been. So for me, it's between $200 and $300. So whichever is closest to that is going to be my answer, and it looks to be like 300. So definitely not 400. Well, it's way too far away. And it's definitely not 500. You might feel a little bit iffy because 250. It's like almost in between 100 and 300, but it is closer to 300. That's one point. The second point is, if you don't like the answer because it's not close enough, don't fudge the line so that it fits what you want it to be. Don't fudge the line to like fit 300. Just redo the line. Let me pick a new color. Sorry for the weird jump in the screen. I see that there's fewer points on bottom than there are on top, so I'm gonna actually move the line up a little bit. And then I'm gonna draw the dot up to the red line now. And in fact, this is closer to 300 for me. So I'm extremely confident now that the answer is definitely 300. The answer is definitely 300, not 100. Número dos, number 2. The function g of x is defined as g of x is equal to negative 2x squared plus 3x. The value of g of negative 3 is negative 27, negative 9, 27, or 45. Let me tell you, the point of this problem, it's literally, it's number 2. It's really meant to see if you know how to do some of the easy problems. It separates you, if you're a struggling student, from students who don't struggle so much, and vice versa. If you don't struggle at all, it separates you from students who struggle a little bit. And how does it separate you? 1, you have to know what a function is, and 2, you have to know how to substitute a number into a function, and 3, you have to know your order of operations, and 4, you have to know how to work with negative numbers. So you have to do all of those things. So that's how I'm going to do the problem. You can do this one on the calculator by pressing y equals, putting this function to y equals, and then plugging in the number negative 3 in your graph. But I'm going to do this the algebraic way because I do need to point out all the little details that they want. So g of x means that g is the function which takes x and does all this crazy stuff to it. So g of negative 3 means, okay, negative 2 times negative 3, x is negative 3, squared plus 3 times negative 3. That's what it is. And now the next step. Do you know how to square negative numbers and multiply negative numbers and use your order of operations? Yes. PEMDAS, spelled G-E-M-D-A-S. G for grouping symbols. Including all parentheses and all other things that group things separately. Exponents, then multiplication, division, then addition and subtraction. And I'm gonna obey this strictly. I know some of you know some tricks to go quicker, but if don't trick yourself into believing you're going quicker and messing up an accident. We're gonna go, there's parentheses, but there's nothing to do in the parentheses, so there's no more parentheses, no grouping symbols. We go to exponents. Negative 3 squared. We know that's how to square. We multiply a number by itself. Most students get that. If they get this wrong, they say negative 3 squared is negative 9. It's not, it's 9. A negative squared is positive. Learn that as a rule. It's a law. Negative 2 times 9 plus 3 times negative 3. No more exponents. So notice I'm obeying these rules, order of operations strictly. Then multiplication and division. Whatever happens first, this multiplication here, let's do those. Negative 2 times 9 is negative 18. Plus, and we could actually do this multiplication now since it's separated. So 3 times negative 3 is negative 9. Okay, and now adding negative numbers. The other part where students get this wrong, they get to this point, then they say negative 18 plus negative 9 is negative 9 because they subtracted 9, which they didn't. They didn't subtract 9. They added 9. Negative 18 on the number line is to the left of 0, right? So if you go to negative 9, you're actually going to the right, so you're adding 9, okay? So on this side, negative 18, here's 0. Negative 18 plus 9 goes this way, minus 9 goes that way. So negative 18 plus negative 9 is actually negative 27. We move to the left when we subtract, so it's negative 27. There we go. Not negative 9, not 29, no. Número 3, number 3, which expression results in a rational number? Radical 121 minus radical 21, radical 25 times radical 50, radical 36 divided by radical 225 divided by, okay, and number 4, 3 radical 5 plus 2 radical 5. So just a fair warning, I was doing this video for number 3 in a different way. I was using the calculator, and the calculator gave me the wrong answer, and the calculator was wrong. This is an interesting case of the software having a bug. And I'm gonna post a video later on. I already recorded the video. I'm gonna post a video later on about me encountering that bug. But for now, I'm gonna do this the algebraic way, the numerical way with a pen. So first, you do need to know, and they're testing you to see, do you know what a rational number is? Yes or no? And do you? Like, are you sure? So here's one good definition. A rational number is a number that can be written as, let's leak down here, a ratio, number over number, okay, of two integers. Yes, they have to be positive or negative whole numbers. The denominator can't be 0. You know that because divided by 0 is undefined. So that's it. So one of these can be written as a ratio of two integers. So let's see what we can do. Number 1, radical 121 minus radical 21. So a lot of students, they'll get tricked by this one and combine radical 121 minus radical 21 to radical 100. Radical 100 is 10. 10 is rational. Done. No. False. That's why they put these numbers here. You have to know that radicals don't obey the distributive property over subtraction. The distributive property is a property of multiplication over addition or subtraction. Multiplication over addition or subtraction. Not every operation. Radicals don't distribute over subtraction. So this number is actually equal to radical 121 does simplify. It's 11 minus radical 121 minus radical 21. 21 is not a perfect square, okay? So this means that this is a rational number, 11, minus an irrational number, which makes it irrational. A rational number plus an irrational number is irrational because a number that can be converted into a fraction times a number that can't, plus minus a number that can't, there's no way to combine to make the second number into a fraction to combine them. So that's number 2, radical 25 times radical 50. This is the one where the calculator actually gave me the wrong answer. Radical 25 is 5 times. Now radical 50 has a very large perfect square factor, radical 25 times radical 2. So 25 times 2 is 50, so radical 50 is radical 25 times radical 2. You might notice I used a distributive property type thing. The radical does distribute over multiplication if you have multiplication only, okay? It does not distribute over addition. The radical does not distribute over subtraction. The radical does distribute over multiplication, and the radical does distribute over division, okay? It's because it's an exponent, okay? So now this is 5 times radical 25 is 5 times radical 2, okay? And 5 times 5 is 25, radical 2. Now this is a rational number times an irrational number. So this is irrational. Why? Because if you have a number that can be written as a fraction and another number that can't, the way you multiply fractions is by multiplying horizontally. You multiply the numerators and multiply the denominators. So if this number was rational, it would mean that the irrational number was also rational, and that's not a thing. A number either can be written as a ratio of two integers or it can't, right? Let's go to number 3. And so let's cross these out too. Number 3. So number 3 says radical 36 divided by radical 225, and this one actually simplifies here quite nicely. Radical 36 is 6 divided by 225. If you go to your calculator, if you don't trust me, 225 is a perfect square. 225 square rooted is 15. Okay, so this is 6 divided by 615, also known as 6 over 15. This sure looks like a ratio of two integers, right? 6 is an integer, 15. Okay, you get it. Number 3 is the choice. Number 3 radical 5 plus 2 radical 5 is equal to 5 radical 5. It's not rational for the same reason that choice 2 is not rational, so that's not it. Numero cuatro, number 4. The math department needs to buy new textbooks and laptops for the computer science classroom. The textbooks cost $116 each, and the laptops cost $439 each. If the math department has $6,500 to spend and purchases 30 textbooks, how many laptops can they buy? 6, 7, 11, or 12. You have a lot of options on how to do this problem. Test numbers out. You know how they're buying 30 laptops, so get the cost of 30 laptops and then figure out how many laptops you can buy to get the cost, to maximize the amount that you spend below or at $6,500. That's a great method. However, a lot of students don't even know how to do that little bit, getting how much 30 laptops cost. You do need to know this, and this is one of those places where working on a little bit of your intuition really helps you. Look, if you buy something that costs you $8, right? Let's say a book costs $8. How much does how much does 2 books cost you? 16, right? 8 plus 8 is 16. How much does 3 books cost you? Okay, 8. Follow me here. You're gonna 8 plus 8 plus 8 is 24, right? And then if I kept asking how much does 4 books cost you, you stop. You're boring me. 8 plus 8 plus 8 plus 8 is 32. I get it. But then if I said to you, how much does 20 books cost you? All of a sudden you're like, and you're like, and then if you're the student, you might say, oh yeah, you went for $8 20 times. Sure. Go ahead. I'll wait. Or you can know what the definition of multiplication is. Why do you use the word times? Historically speaking, the reason we use the word times is because multiplication is a repeated addition. That's what it is. So buying an $8 book 20 times, 8 plus 8 plus 8 plus 8 plus 20 times, 8 times 20. That's how you do these multiplication problems, these cost problems. All of them, they're always asking you the same question. Sometimes you need a variable, sometimes you need numbers, but always it's the cost times the number of things that you buy. Always. So let's do that. Here, the textbooks cost $116 each and the laptops cost $439 each. The math department has $6,500 to spend, purchases 30 textbooks. How many laptops can they buy? Well, first we need to know how much we have left to spend after we purchase the 30 textbooks. Okay, so how much the textbooks cost? The textbooks cost $116 each. 2 textbooks, add 2. 3 textbooks, add 3. 4 textbooks, add the number 4 times. 30 textbooks, add the number 30 times. 30 times 116. So textbooks cost 116 times 30, and let's get the calculator out. Cool. 116 times 30. Okay, so that's 38, 434.80. 34.80. Cool. Yeah, textbooks are expensive. Cool. Remaining money. Equals, it's a 6,500 minus the 3480. And this one I can do in my head, but you can do on the calculator, and you should do on the calculator if you don't want to mess up. So 3020. Okay, so that's how much money is left. How many textbooks, how many laptops can they buy now? So it's, again, this is where we introduce a variable. The cost of laptops times the number of, the cost of the laptops is the cost of 1 laptop times the number of laptops we buy. We know the cost of 1 laptop, so we need a variable to be the number of laptops. So let L equal the number of laptops bought, okay? Okay, so the cost of 1 laptop, $439 times L has to be equal to 3020. Now, if you're smart, you might know that no, it doesn't have to be equal to 3020 because you can't buy a third or a fifth or 0.7 or 83% of a laptop. So actually, we solve for L. We divide by 439. Sorry for the space. I'm actually running out of batteries in my camera. 439. Bad things happen when you're making videos. 439. L equals, and thank you for having patience for me. I'm doing the best that I can for you guys. And to get this out for you as soon as possible, while being, of course, legally within the time limits that I'm allowed. 439. Okay, so 6.879 laptops, and if you could buy 0.879 laptops, then great. If you could figure out how, let me know. So 6.879. So L is actually equal to 6. And a lot of these problems, they actually purposely make it so that you have to round down even though the number is big, just to see if you know that you're supposed to round down, because you can't buy 0.879 of a laptop, and that's true for any physical unit object. So the answer is 6. Okay. Well, interestingly, right when I finished recording number 5, the camera actually died on me, so I'm actually really appreciative that you guys were patient with me while I did number 4 so rushed with all the weird random mistakes. The reason I don't want to do so many edits is because I really want these videos to be out for you as soon as possible, as soon as I'm legally allowed to post the solutions. Oh, by the way, I made a wardrobe change. Here's the t-shirt in the baseball style. Again, the link is below. If you want to support me by buying one of these t-shirts and also just represent your nerdy style, you can purchase one of those from the link below. I use the money that I make to purchase new equipment. For example, I need a new battery attachment for this GoPro so that I can actually record for longer periods of time between breaks. And also, if you want to support yourself while supporting me, you can purchase the study guides that I have, the baseline, the midterm, the final, with the student-ready solution sets that tell you exactly where to go to study stuff that you don't know how to do, and they're super affordable. And just for you guys, since you were supporting me by watching this video and by tolerating the way I recorded number 4, I'm going to lower the price by 20% for the next week. So you can definitely check that link out, and that's just for you. Thank you for watching this video. And listen, I know you could do it. I'm doing this for you, and you would be doing that for yourself too. So I'm glad that you're here with me. Let's go out to number 5. What is the solution to the equation 3/5 parentheses x plus 4/3 equals 1.04? So these are weird answers. I've never seen a problem like this, and I like it. 3.06 repeating, 0.4, negative 0.48 repeating, and negative 0.709, 3 repeating, just the 3 repeating. So I like this question. I've never seen a question exactly like this on the Regents before, but they can ask this on the ACTs and SATs. I mean, they can, because they do on the state tests, right? So there's a few ways of doing this. You could do it the algebraic method, divide by, multiply by 5/3, subtract 4/3, see what the calculator tells you. You can do this by plugging in each answer or any approximation of the answer and see if you get really, really close to 1.04. And those are 2 options, and both of those will work. I want to show you as many methods as possible because, again, I'm doing this for you, and I want you to get the highest grade possible on this test. Sorry for that flicker. That was my recording apparatus. So I'm going to do this by the calculator method. So I'm going to press y equals, and there's a trick, a really useful trick on the ACTs, SATs, and on state tests, to have the calculator solve algebra problems for you, even when you don't necessarily know how to do the algebra. So, and even though the calculator doesn't know how to do algebra, so what we do is it only knows arithmetic. It only knows what you typed in. 3/5 times parentheses x plus 4/3. Okay. That's the left side of the equal sign, and then the second equation is going to be y equals the right side, 1.04. Okay, and what am I going to do with this? I'm going to press zoom standard to reset the graph bounds, and this is the value of the left side of the equation, and this is the value of the right side of the equation. The first graph is the value of the right side of the equation for all values of x from -10 to 10 in this graph, and if I expanded the graph as much as I want. And the right side of the second graph, that horizontal line, is the right side of the equation. So it's 1.04 because it's constantly 1.04 for every single value of x. There's no x there, so it doesn't change. So how can we get the calculator to do the algebra for us? Well, here's the thing. The first graph is the set of x values that make the left side true for a given x and y coordinate, and then the right side, the second graph, is the set of x and y values that make the second equation true. So the intersection of these two graphs is the set of y values, x and y values, that make both equations as we type them true. And in this case, what it implies is that it's a set of the x coordinate of this is the solution to the equation, the left side equaling the right side. So how do we get that intersection? We can estimate, drag it around here. It looks around 0.4, but I mean, we got a 0.4, we got a 0.48, negative 0.48, repeating a negative 0.7093. I suspect that the answer is going to be 0.4. I really think it's going to be, because it looks like the intersection is positive, but how can we get the intersection exactly? The calculator does the intersection exactly. Look at this, calc. So it's in blue, so we press the blue second button, second calc. Intersect is this one. There's only two curves, so the first curve, enter. The second curve, there's two curves. Guess, get close to this intersection, press enter. And x is 0.4, so this is the exact answer. Nice, right? The calculator can do algebra for us. Numero 6, number 6, the area of the rectangle is represented by 3x squared minus 10x minus 8. Which expression can also be used to represent the area of the same rectangle? Let's see, 3x plus 2 times x minus 4, 3x plus 2 times x plus 4, 3x plus 4 times x minus 2, and 3x minus 4 times x plus 2. It's one of these. So if this is the area of the rectangle, right? This is the area. It says it's the area of the rectangle. It seems, it's weird because they're saying the area isn't 42. It's not 57. It's not 8. It's this expression, right? So this is the area. And so then they're saying which expression can also be used to represent the area. Okay, so we're not trying to solve for the base, we're not trying to solve for the height. That is semi-arbitrary. Most of the time when they ask you to do this problem, they want you to factor, but they're asking for the area. Okay, so in this case, they actually are saying, can you factor this polynomial to get these, the answer? Like I said, there's a few ways to do this. I just did number 5 by graphing. You can graph 3x squared minus 10x minus 8, and then graph each one of these choices and see if the graphs match. If you get the same graph, the answer is right. So, but what I'm going to do is I'm going to actually do the algebra for you. I'm going to show you how to do this algebraically, how to factor this. It's a really cool method. I like to call it the AC method. A lot of teachers call it something different, but it's a method. It's an expansion of the method of like looking for numbers that add up to B and multiply to C. So we're going to do 3x squared minus 10x minus 8. Now, how do I know that I'm going to factor this? Because these 4 expressions are all factored polynomials, factored quadratic equations, and there is only one way to factor this polynomial, right? So there's only one way to do this. So the method of doing this is saying that B, so that two mystery numbers, okay, add up to B, which is equal to negative 10, okay? So two numbers add up to B. Those same two numbers, when multiplied, have a product equal to not C, because A is, when it's C, A would have to be equal to 1. In fact, we need it to be equal to AC, okay? So AC is 3 times negative 8, which is equal to negative 24, okay? Two numbers whose product is negative 24 and sum is negative 10. There's infinitely many choices of integers whose sum is negative 10. There's only a finite number of integers whose product is 24. I like to do what's called the factor rainbow, 24. Connect 1 and 24. The next number after 24, 1 is 2. 2 is a factor of 24 with a factor pair of 12. 2 times 12 is 24. 3 is also a factor of 24. 3 is a factor of 24. 3 times 8 is 24. another factor of 24. Cool, 4. You see why I call it the factor rainbow? 4 is a factor of 24 with a factor pair of 6. Cool. 5 is not a factor of 24, so we don't use it. And then 6 is already on the list. It's written right here. That's the hint. That's the exact time you stop. These are the only factor pairs of 24. So again, you start from 1, go up, 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 until you actually get a repeated number. And one of the repeated number is actually the last bigger number, the 6 in this case. So these are the factor pairs whose product is 24. We need one of them to be positive and one of them to be negative for the product to be negative. And their sum has to be negative 10. So let's see, 1 and negative 24 is negative 23. Negative 1 and 24 is positive 23. Okay, that's not it. So 2 and 12. Negative 2 and 12, that's 10. That's positive 10. Okay. Positive 2 and negative 12. There it is. Positive 2 times negative 12 is negative 24. And 2 plus negative 12 is negative 10. So 2 and negative 12 is negative 24. 2 plus negative 12 is negative 10. Those are the numbers. How are we going to use them? We can't just factor right away, unfortunately, like the other method, but we can use this to factor by grouping. I know some students factor by grouping just by intuition, looking for the numbers until they find them. This method, this AC method, is factoring by grouping, but it actually algebraically finds the numbers for you. There is no guess and check. The numbers are for 2 and negative 12. So 3x squared plus 2x minus 12x. So there's the 2 and the negative 12, and then minus 8. These are the exact number choices that allow you to factor by grouping. We found them. We actually calculated them. A lot of students guess and check. I like this. So now greatest common factor of 3x squared and 2x is x times factor pair 3x times 3x is 3x squared, and x times 2 is 2x. And then we need a plus something times 3x plus 2 is going to be the factor pair. And what factor pair is this? This is the only part where that gets a little tricky. Sometimes you have to factor out a 4 or some number or the negative of a number. In this case, if I factor out a negative 4, I get the correct factor pair of 3x plus 2. So that way, that works. 4 times negative 4 times 3x is negative 12. Negative 4 times 2 is negative 8. Perfect. And now I factor by distributive property, x minus 4 times 3x plus 2. And one of these is exactly that. X minus 4 times 3x plus 2. This is it. Isn't that cool? I like it. Número 7, number 7. Which relation does not represent a function? This list of x and y values, this expression involving y and x, this graph, and then this set of arrows. Look, so if you know the answer to this question, congratulations, because they're gonna keep asking you this question. They keep doing it. You know that. So if you don't know what a function is, you gotta know what a function is. There's no excuse for it, because really, they don't really ask many questions above what is a function, right? And they don't say what is a function and say this other thing about the problem for one multiple choice question. They always ask which relation does not represent a function and what does not represent a function. So this is what a function is. So a function is a relation that does not repeat x values with a giant dot period at the end of the sentence. That's all that a function is. You pair a bunch of x and y coordinates. You could do that all you want for any relation. In fact, that's all the relation is. It's a bunch of pairings of x and y coordinates. Every graph is a relation. Every table of values is a relation. Every scribble on a graph paper is a relation, because that scribble contains points, and those points are part of the relation. But a function just doesn't repeat x coordinates. That's all it is. So function graphs pass the vertical line test. Okay? Test. So let's look at number 3. This says which relation does not represent a function. So for example, if I draw every single vertical that's sort of vertical. Every single vertical line that I draw through this graph only crosses the graph once. It has to be vertical line, only crosses the graph once. So in other words, what is the vertical line test? It makes sure that at every single x coordinate, there's only one y coordinate. It does not repeat x values. So this first one, look at 1, not repeated. 2, not repeated. 3, doesn't appear. 4, not repeated. 5, not repeated. 6, not repeated. Cool. Now, I never said anything about y coordinates. X can't repeat, and that's the end of the sentence. X can't repeat, and that's the end of the sentence. So this is a function. This is also a function. Number 3, y equals 3 radical x plus 1 minus 2. If you don't believe that that's a function, let's graph it. Oops. Y equals, let's clear out that algebra problem we did. Okay. And let's say y equals 3 square root x plus 1 out of the square root and then minus 2. Let's graph it. Does this pass the vertical line test? So this passes the vertical line test. In other words, if you plug in an x coordinate, you only get one y coordinate, so it doesn't repeat x values. So now this one, so this is a function. So it has to be this one, does not. So this is yes, 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 and no. Why is this one no? Look at that. Look at this 1. It gets repeated to number 4. It also gets repeated to the 5. So 1 gets repeated twice. 2 gets repeated once and again. 3 gets repeated once and again. So these each actually get repeated twice. So this is not a function. Okay, that's all a function is. Can't repeat x values. Numero 8, number 8. Brittany is solving a quadratic equation. Her first step is shown below. Problem 1. 3x squared minus 8 minus 10x equals 3 parentheses 2x plus 3. Step 1. 3x squared minus 10x minus 8 is equal to 6x plus 9. Which 2 properties did Brittany use to get to step 1? And the properties are, let's see, addition property of equality, commutative property of addition, multiplication property of equality, distributive property of multiplication over addition, and then the choices 1 and 3, 1 and 4, 2 and 3, or 2 and 4. So we know we're definitely using either 1 or 2, and we're also using 3 or 4 based on the choices, the combinations of the choices. So let's see what she did. We do need to know what each of these are. The addition property of equality. The addition property of equality says that if you have an A and equals a B, and then you add a C to both sides, that you're allowed to do that. And you frequently do that to solve equations. A plus C equals B plus C. But normally what you end up doing is not to add a mysterious C. Sometimes, rarely you do, like in completing the square. But what you normally do is you actually use this property to eliminate something. So you usually, if it's an A minus C equals B minus C, you usually do plus C and plus C on both sides to cancel out the C. But the point is that you can always do that. If you have 2 numbers that are equal and you modify them the same by adding the same number, you get 2 new equal things. That's the additive property of equality. And on this one, I don't see her adding 2 things to both sides. Okay, so or 1 thing to both sides. So it's not the addition property of equality. So we're gonna eliminate number 1 and choice 2. So because we know what she's gonna use 2, the commutative property of addition. And it might feel like, well, she's not adding here, but remember that addition and subtraction are equivalent operations. They're inverse operations of each other because they're equivalent to each other. Subtracting is equivalent to adding a negative, right? So what she did here, the commutative property of addition, she took this minus 8, which is plus negative 8, she moved it to the end, and this minus 10x, she moved it to the middle. So she literally commuted these 2. Commute means to move. So that she definitely used the commutative property of addition, okay? So that part is right and that part is right. Now let's look at the third and the fourth choice. The multiplication property of equality. So the multiplication property of equality is similar to this one. Like if you have an A equals b, and you want to multiply both sides by the same number, let's say times d, I don't know, times d, that you could do that. And then you get AD equals BD. And normally, of course, we do this to cancel out an addition. But the point is that you can do this anytime the left side equals the right side. And you get two equal things. But in this case, she did not multiply both sides of the equation by the same number. So it's definitely not going to be this. So it's not going to be this. And so it's not going to be choice 3. Distributive property of multiplication over addition, she did do that. She used the distributive property here. So it is number 4. Number 9, the graph of y equals 1/2 x squared minus x minus 4 is shown below. The points A, -2, 0, B, 0, -4, and C, 4, 0 lie on this graph. Which of these points can determine the zeros of the equation y equals 1/2 x squared minus x minus 4? A only, B only, A and C only, or A, B, and C? Not a fan of this question. I won't even be surprised if they eliminate this question from the test. They don't have to, but I wouldn't be surprised if they do, because technically there are 2 answers and they're usually quite careful about how they word this question. The reason there's 2 answers is that any parabola is uniquely determined by 3 points. So A, B, and C would be a good answer. However, it would be the answer if they didn't give you the zeros of this parabola. Now, a quadratic equation can only have 2 zeros. So that's why in this case there's actually another answer that this problem has. Point A, -2. So it does say that these points lie on the graph, and it confirms that they do. Point A, -2, 0 is on the x-axis because the y-coordinate is 0. So that is a 0. Okay, that's a 0. And then point B, 0, -4. A lot of times students see this and think it's a 0. It's not. That's a y-intercept. Okay? It's not a 0. A 0 is a point where the graph crosses the x-axis. More specifically, it's an x-coordinate where the graph crosses the x-axis, or in other words, a x-coordinate where the y value is equal to 0. So in this case, they gave us a 0. This is point A. So -2 is a 0. B, this is a y-intercept. This is not a 0. So -4 is not a 0. 0 is not a 0. And the third point, C, 4, 0, is right here. This is C. So 4 is also a 0 of this equation. So we have the 2 zeros, A at -2 and C at 4. So A and C do give you the zeros of the equation. So 3 is the answer, and A is definitely not enough. Not a single point can never determine all the zeros of a quadratic equation. A single point can't do it. So A is wrong. But because A and C gave you the zeros, then 4 is enough. 4 is not the right answer. Again, this specifically uses the fact that this is a quadratic equation. If it were something else, a cubic, quartic, then you'd need more points. But this is a quadratic equation. A parabola only has 2 zeros. Numero 10, number 10. Given the parent function f of x equals x cubed, the function g of x equals x minus 1 cubed minus 2 is the result of a shift of f of x. Let's see, 1 unit left, 2 units down, or 1 unit left and 2 units up, or 1 unit right and 2 units down, or 1 unit right and 2 units up. So you should, by the way, you should always do these problems on your own. You can definitely do this problem by graphing it, and I highly recommend graphing it if you don't know the answer. And I will graph it, but I won't tell you the answer based on the graph, because if you don't know how to do it based on the graph, then you got to move on to another method, which is, I'm going to give you the more algebraic method, which is an extremely relevant method. I'm going to clear this out. So g of f of x equals x cubed. Okay, and then g of x is equal to, it's definitely a transformation of the original, x minus 1 cubed, minus 2. Okay, and now I'm going to zoom standard so that it gives me the standard graph, and I'll adjust the zoom if I need to. That was the first graph. That was y equals x cubed. And the second one that it just graphed is y equals x minus 1 cubed minus 2. So if that one tells you the answer, great. If not, then listen to this conversation. In the way I'm going to explain it is this, and this every time I explain it to students this way, they get it. So listen, any transformation that you perform in the y direction using numbers is done as you would naturally expect it. Adding 1 shifts the graph up vertically. Adding c shifts the graph up vertically, c units. Subtracting c shifts the graph down c units. Multiplying by c stretches the graph by a factor of c vertically. And then, so on the other side of it, if you work with the number c on the x coordinate, literally perform the operation on just x by itself, it does exactly the opposite of what you would expect it to do on the y, in the y direction. And there is a reason for that, but it's a little bit too deep for now. But for example, if we take x and we add c to x, we would expect the graph to move c, like just intuitively speaking, without even thinking about it, we would expect the graph to move c units to the right. No, but if we add c, it actually moves c units to the left in the negative direction. Okay, which is the opposite of what happens when the vertical direction. If we subtract c, we like intuitively expect, just like the graph would move down if we subtracted c from the whole thing. If we subtract c from x, the graph actually moves in the positive direction, okay? And then if we multiply x by c, if we multiply the whole expression by c vertically, we expect it to stretch by c vertically. But if we actually multiply x by c, it actually narrows the graph. So it does exactly the opposite if you perform the operation on x horizontally as what happens if you do the same operation on the entire expression vertically. So in this case, subtracting 2, we expect subtracting 2 from the entire expression x minus 1 cubed to shift it downward 2 spaces. So down 2. Cool? So it's definitely going to be 2 units down. So this is right so far. This is wrong. Good. This is right so far, and this is wrong. So 2 and 4 are not the answers. And now we're 50-50, which is great. Taking a problem from 1 and 4 to 1 and 2 is great. It gives us a 50% chance of getting it right. This on the ACT, it's a 1-point question, so that is equivalent to getting a half a point. On the Regents, it's actually a 2-point question, so it's equivalent to getting 1 point now. So now, is it 1 unit left or 1 unit right? So this, we're subtracting 1, so we expect it to go in the negative direction, but it actually goes in the positive direction. It always does the opposite in the horizontal direction. So this is actually 1 unit right. If we subtract 1 from everything, it goes down in the negative direction. So in the horizontal direction, it does the opposite of what we would normally expect. So instead of going in the negative direction, it goes in the positive direction, 1 unit right. So it is this, okay, and not this. So not that and this, okay? Número 11, number 11. If c equals 2a squared minus 5 and d equals 3 minus a, then c minus 2d equals 2a squared plus a minus 8, 2a squared minus a minus a, 2a squared plus 2a minus 11, or 2a squared minus a minus 11. So let's see if we can do some process of elimination here. Process of elimination could take you a really long way to getting an extremely good grade on the SAT, on the ACT. So my process of elimination says it's c minus 2d, so it's c minus 2d. So I'm subtracting 2 times this from this, and I see immediately that if I subtract 2d, I subtract 2 times 3 is 6. So I subtract 6. So minus 5 and minus 6 is going to be minus 11. So immediately I see these might be the answer. This is good so far. This is good so far. This is not good. This is not good. So it's not 1 and it's not 2. So quickly, I went from 1 in 4 chances of getting this question right to a 1 in 2 chance of getting it right. So this problem went from being valued out of a half a point out of 2 to being valued 1 point out of 2. Big deal, because they don't require that many points to pass this Regents. 27 points for this Regents, which is crazy. It's literally getting 14 questions right in the multiple choice and getting nothing else right. Anyway, that's one of the complaints that I have. I think it should be more realistic in terms of measuring skill. But okay, let's keep going. So which one of these is it? I'm subtracting a negative, which makes me think it's going to be plus. So I think it's going to be this. I like this. So let's see. Let's actually do the algebra though. Let's go up here. C minus 2D equals 2a squared minus 5 minus 2 parentheses 3 minus a. And this tests if you could do the distributive property. If you know that this is true at this point, you just perform the distributive property carefully. Let's see, 2a squared minus 5. 2 mistakes that are common in the distributive property so that you know. Distributing the minus 2 to the 3, but not to the a. That's the biggest, most common mistake. The second most common mistake is distributing a minus 2 to a minus a and somehow keeping a negative sign because there's 2 negative signs already, so might as well keep one of them. When in fact, 2 negative signs when multiplied cancel. The product of 2 negatives is a positive. So distribute the negative 2 to the 3 and to the negative a. Negative 2 times 3 is minus 6. Negative 2 times negative a is plus 2a. And now we combine like terms and put in decreasing exponent order. 2a squared, and then the a terms plus 2a. And then the minus 5 and the minus 6 is minus 11. So that's it. Number 3, and I was right about that plus. Gosh, it's almost like I actually know what I'm doing when I saw that plus, but it's not meant to be a humble brag. It's actually meant to be to show you what I do to solve some of these questions. The process of elimination is an extremely important skill to have, and it actually isn't that tough, even for students who struggle with a lot of the basics maths. You could be at 50% level on the ACT, and you could actually perform process of elimination. One of the things that I used to tutor students to do on the ACT is process of elimination, looking at the answers they know are wrong, looking at the answers they think are wrong, looking at the answers that look funny, and just crossing those out, and then guessing from there. If they didn't know how to do the question, if they did know how to do the question, they should do it. If they know how to do the question partially, they should do the question partially. And then if they still can't finish it, then they should eliminate the answers they know are wrong, eliminate the answers that they think are wrong, eliminate the answers that you think are wrong, that look funny, and then guess from there. I was able to eliminate 2 answers because I knew they were wrong, because negative 5 minus 6 is negative 11. You see? 50% chance of getting it right at that point. And if I could quickly speak about expected value, the expected value of the question is the probability, the number of points that it's worth times the probability of you getting it right. So it's an extremely relevant thing to calculate when you're taking the test, because you're not going to know how to do every single question. So it's the expected value that you want to increase. The expected value of a question you exactly know how to do is definitely 1 point on the ACT. The expected value of a question that you leave blank is 0, so you should never leave a question blank. And that's true on the SAT too. The expected value of a question that has 5 choices, 5 choices, is 1/5 times the value 1, which is 1. So if you eliminate 3 of the choices and you have 2 left, the expected value of that is 1 divided by 2, 1/2. That's actually 150% increase in the value of that question. Seems weird. That's the way it works. Let's do number 12. Mark bought a new laptop for $1,250. He kept track of the value of the laptop over the next 3 years, as shown in the table below. Years after purchase, value in dollars, and I look at tables cursorily because I know I'm gonna have to look at them later. Years after purchase, value in dollars, 123, 1,800, 640. Okay, which function can be used to determine the value of the laptop for X years after the purchase? F of X equals 1,000 times 1.2 to the X. F of X equals 1,000 times 0.8 to the X. F of X equals 1,250 times 1.2 to the X. And F of X equals 1,250 times 0.8 to the X. But do this question on your own. See if you could use that process of elimination that I just taught you to eliminate a question, and then see what I do. So here's what I do. The value of a laptop, so now I have to look at the value. He bought a new laptop for 1,250, so that's going to be a relevant number. And then he kept track of the value of the laptop, and it looks like year 1, 1,000, year 2, 800, year 3, 640. So it looks like it's going down in value, over time. That's an extremely relevant thing to note. And in fact, if you want to pause now and guess, I highly recommend it. So now what do? I notice that, let's see, the value of this 1.2 to the x power, 1.2 is bigger than 1, so the exponential function is actually going to increase as time goes on. So this is not the right answer. And same deal here, 1.2 to the x, this is going to increase as time goes on, so this is not the answer. Now I got a 50-50 chance of getting it right. So it's either 1,000 times 0.8 to the x or 1,250 times 0.8 to the x. At this point, I'm starting to suspect that this one versus this one uses 1,250 as the initial value of the laptop. So I actually suspect that this is going to be the right answer because of the 1,250. Now let's see if I'm right. The equation for an exponential decay of a value is equal to, so f of x is equal to f of 0, the initial value, okay, times 1 minus the rate of decrease to the power of x, where x is in years, okay? So this is equal to f of 0 is 1,250. And now I could see that the amount that it decreases is actually, well, I actually know it's going to be 20% because these bases are the same, and I can confirm it by doing, let's see, let's quit here, 1,250, nope, 1,000 divided by the final divided by initial, because it's a product, so final divided by initial, so 1,250 is 0.8, and that confirms the 0.8. 0.8, okay, and then to the power of the year. And so this is the answer. F of x equals this, okay. Number choice 4. What I just talked about is extremely important. The answer is not the important thing, the method is what's important. I tell that to all my tutoring students, and the ones who accept that progress more quickly. All my students progress eventually, but the ones who accept that really progress fast. I've taken so many students from the 70% level to the 90% level in just a few days, literally a few days. I've taken students that have gotten 18s on their ACTs to getting 31s on their ACTs in a week and a half, so frequently, not even rarely. So that's relevant. So take the advice that I give you, all the little hints that I give you along the way. That's free 99 knowledge. Take it. Number 13. The height of a ball Doreen tossed into the air can be modeled by the function h of x equals negative 4.9 x squared plus 6x plus 5, where x is the time elapsed in seconds, h of x is the height in meters, and the number 5 in the function represents the initial height, the time at which the ball reaches the ground, the time at which the ball was at its highest point, and the maximum height the ball attained when thrown in the air. Try the problem. If you know your physics, you might be able to answer this question. Let's look at the problem and see if we get some information, because it does tell us some of the information. The h of x is the height, the height at all times, okay? So this is the height, right? the x is the time elapsed, okay? And then, so let's see what we can eliminate here. The initial height of the ball, that seems to make sense. Since this is by itself, its units are the same as the original function, so it's a height, okay? So this looks good. The time at which the ball reaches the ground, this is not x. X is the time, so x is time, okay? X is time, so the time at which the ball reaches the ground, no. The time at which the ball is at its highest point, no. X is the time, okay? So, no. And the maximum height of the ball attained when thrown into the air. This might seem like okay, and then you could graph it because it is a height, but if you graph it, you find out that that's not the case. The second thing is that if you plug in x equals 0, the 0 time, you get negative 4.9 times 0 is 0, plus 6 times 0 is 0, plus 5. So this is 5 is the value of the function at x equals 0. So 5 is equal to h at 0, which is the initial height. So it's definitely this one. And in fact, the maximum height of the ball doesn't occur at this constant. This is actually an extremely common question. Remember to take my advice, the maximum height occurs at the vertex. The vertex. And where is the vertex? At x equals negative b over 2a, which is equal to negative 6 over 2 times negative 4.9. Get the calculator out and find out what that is equal to. And then the max height equals h of whatever negative 6 over 2 times 4.9 is. So negative 6 over 2 times negative 4.9, whatever that happens to be. That's the maximum height, and that height is bigger than 5 because it's initially being thrown up in the air, okay? Numero 14, number 14, the function f of x equals 2x squared plus 6x minus 12 has a domain consisting of the integers from negative 2 to 1 inclusive. The integers from negative 2 to 1 inclusive, okay. Which set represents the corresponding range values for f of x? Let's see, negative 2, negative 20, negative 12 and 4, negative 4, negative 16, negative 12 and 4, or negative 2 and 4, or negative 16 and negative 4. I'll definitely try this problem on your own. See what you think about it. I think that you should give yourself the chance to think about this question, because if you think about it for a little while, you might find that it's actually not as hard as you think. Take a guess at what you think is right. And then try to do everything right by this problem, okay? I'm gonna continue now though. So the domain is the integers from negative 2 to 1 inclusive. So the domain is equal to the set negative 2, negative 1, 0, and 1. And that's the full domain, 4 numbers in the domain, not the full interval, just those 4 numbers. Okay, so what's the range? The range, if we repeat numbers, this might repeat numbers, but then the repeated numbers aren't really repeated. They're just appear once in a set. They appear twice in a graph, but once in a set. So this is f of negative 2, f of negative 1, f of 0, and f of 1. Okay, this is commonly denoted as f of d, f of the full domain. So this is a set. It's a shorthand notation. Okay, so how do I evaluate this? I'm going to show you how to evaluate this using the calculator in a very quick way. You can plug in one of these numbers to eliminate some choices. Like I see that all of these have negative 4 in them. So, if I plug in though x equals 0, I can quickly evaluate this function. F of 0 equals 0 plus 0 minus 12. There's my process of elimination. Choice 3 and choice 4 are eliminated, and because these both contain negative 12. Now I'm going to evaluate it in the calculator so I can show you how to do it. But pay attention to that process of elimination. That's what you're paying me $0 for, to give you the best advice possible. What I charge a very large amount of money to tell students. So I'm going to put f of x equals 2x squared plus 6x minus 12. Okay, and then what I'm going to do is I'm going to go to the table. Let's see how the table looks. The table. So I'm gonna show you what I did. Table set is in blue, so second table set. I make sure that the independent value right now is set to auto, and the dependent value is set to auto. The delta table is usually set to 1 automatically, and table start is usually set to 0 automatically. So I put those at 0, 0, auto, 0, 1, auto, and then I can scroll up and down here. So negative 2, f of negative 2 is equal to negative 16. Okay, so this is the set containing negative 16, comma, f of negative 1 is actually also negative 16. So that's already on the list. Great. And then f of 0 is negative 12, negative 12. And then f of 1 is equal to negative 4, negative 4. And this is the range. Okay, so it's choice 2. Not choice 1. And I want to be honest with you, if I could take a pause for a moment. One of the reasons that I suggest purchasing the resources that I have for prepping for the Regents in Algebra 1, and also for the SAT and for the ACT, is that I knew a long time ago that the best way to make money is to actually offer a good product, whether that's your hands, your work, your art, your music, or whatever product that you sell in your business. Me, I sell my knowledge and my teaching ability, and also the products that I create and publish online. And I do that with the goal of producing quality, not with the goal of producing money for me. Because if I try to produce money for me, I know that I won't make money, because the purchaser will look at the product I bought and not like it, and not buy anything else, and not recommend me to anybody else. In this case, I want you to have the best product that's possible, and I'm selling it for a very low price, and I want you to do the best as possible on this test and on any future test. So I do highly recommend that you purchase those. To do yourself a favor, you support yourself by supporting me. I believe that you can do it. I know that you can do it, and I believe in you. So definitely check those out. Number 15, which equation has the same solution as x squared plus 8x minus 33 equals 0? Let's see. There's a bunch of these. X plus 4 squared equals negative 49. X minus 4 squared equals negative 49. X plus 4 squared equals 17, or x minus 4 squared equals 17. So definitely try this problem on your own. Like I said, you can do this problem by graphing all of these one at a time. I'm going to show you a quick cool trick to graphing, because I know that graphing calculator doesn't differentiate, especially if you have the non-color one. They have a really cool color calculator now, which is phenomenal. If you graph these two functions, let's say I'm going to graph one and the original and choice 1, x squared, okay, plus 8x minus 33 equals 0. So which equation has the same solutions as these? And then x plus 4 parentheses x plus 4 squared equals 49. So I need to have equals 0. So minus 49 minus 49 minus 49. So to get 0 on the right. Okay, minus 49. Okay, now what the trick I'm gonna use is this. If this will happen to be the left side and the right side happen to be the same exact expression, you might notice that the calculator wouldn't differentiate between the two, because the thickness of the lines are different. So what I do is I actually make one thin and one thick, and then I graph them. And if they overlap, you'll see that the line gets thicker. All right. So that's that graph, and then that new graph. So it looked like the graph that I just chose happened to be the right answer. So let's do zoom fit. Zoom fit is a nice little tool that changes the y coordinates, the min y and the max y, to fit the graph. So let's see. Bam, that's the original function. And this is choice one. Notice choice one hovers exactly on top, and you can actually see that graph being created. So this one seems to be right. In terms of process of elimination, this is a minus sign. So, and this is a plus. You can get these equations by completing the square. So and when you complete the square, this plus is going to be maintained. So it's going to be either choice one or choice three. This has a minus sign, so that's not it, and this has a minus sign, so that's not it because of the minus sign. So, but it does turn out, as we checked on the graph, that it's number one. Okay, done. Feel free to ask any questions in the comments below. I will respond to your comments. Number 16, número 16. The table below shows the weights of Liam's pumpkins, L of W, weights of pumpkins in pound, and Patricia's pumpkins, P of W, here over a 4-week period where W represents the number of weeks. So W weeks. Okay. Liam's pumpkins grow at a constant rate. Okay. Patricia's pumpkins grow at a weekly rate of approximately 52%. Okay. And let's see. So these grow at a constant rate. 2.4, 5.5, 8.6, 7.7. So that's a linear function, okay, because they said it's a constant rate. And then Patricia's pumpkin grow at a weekly rate of approximately 52%. Okay, this is exponential. Okay, so cool. So assume that the pumpkins continue to grow at these rates through week 13. When comparing the weights of both Liam's and Patricia's pumpkins in week 10 and week 13, which statement is true? Liam's pumpkins will weigh more in week 10 and week 13. Patricia's pumpkins will weigh more in week 10 and week 13. Or Liam's pumpkins will weigh more in week 10 and Patricia's pumpkins will weigh more in week 13. Or Patricia's pumpkins will weigh more in week 10 and Liam's pumpkins will weigh more in week 13. In other words, which one's going to be which weight in week 10, which week 13? They literally could have said Patricia's weights are going to be this and this at these weeks, and Liam's are going to be what on these weeks, because that's really kind of the only way to do this question. You have to find out how much they weigh at week 10 and week 13. So how do I do this? I do 10, 11, 12, 13, and then I do let's see, get my calculator out. How much this one is Liam's is growing at a constant rate of so from 2.4 to 5.5. Let's confirm that. This is let's see, so the difference here, 5.5 minus 2.4 is 3.1. Let's confirm that difference is constant. 8.6 minus 5.5 is 3.1 according to my calculator. I have one installed in my brain. 11.7 minus 8.6 is 3.1. Cool. And these grow at approximately 52%. So we know that this is times 1.52. And of course there's some decimal approximations. So that's how I'm going to get to the next one. This one had to be calculated. So I'm going to do Liam's first. So I'm going to do the 11.7. Good. The next weight is going to be that plus 3.1, enter, 14.8, okay? And I typed it in this way because to get the next one, it's answers plus 3.1, so it's this answer plus 3.1, enter, 17.9. The next one, 17.9 plus 3.1 is 21, and then the next one is 24.1, 24.1. Okay, now I suspect strongly that Patricia's are gonna be way bigger because hers grow at 52%. Exponential functions grow faster than linear functions, and eventually any growing exponential function will surpass any growing linear function. That's how fast exponential functions eventually grow. And these weights are already close to each other, and a growth of 52% is extremely fast. So I need to do 8.8 times 0.52. So 8.8, not times 0.52, times 1, clear, times 1.52, enter, 13.376. 13.376. So I'm going to circle the one that's bigger. So in other words, it weighs more. So Liam's weighs more in week 10. So here, Liam's will weigh more in week 10. This is so far right. Patricia's will weigh more in week 10. No, it won't. So that's number 2 is wrong. Liam's pumpkin will weigh more in week 10. This looks good. And Patricia's pumpkin will weigh more in week 10. This is wrong. Okay, so it's now number 4. I suspect strongly that Patricia's is going to weigh more in week 13 by a whole lot, in fact. So I think that this is going to be the case, okay? I think it's going to be choice 3. Let's find out. So the 10th week times 1.52, enter. Let's see, 20.3. Let's put 20.3 because the calculator is going to store all the decimals. So 20.3, and it's already, Patricia's is already heavier. Now you see 17.9 and 20.3. Let's see the next one. If I'm right and the exponential functions grow extremely fast, the next number should be way bigger than the 12th week for Liam's of 21 weeks, and this is 30.9 pounds. 30.9 lbs. Compare week 11. Week 11, they're different by about 2.5 pounds. Week 12, they're different by about 10 or 11 pounds, about 10 pounds. And week 13, 46.97 pounds. So it's actually 47 lbs. Now they're different by almost a factor of 2. So I was definitely right. Patricia's is going to be way more, way more. Her pumpkin's going to way more. Week 13, so that's definitely the right answer. This is not right. Número 17, number 17. The function f of x is graphed below. Okay, cool graph. It's like a v, maybe an absolute value type thing. But there's a point, so it doesn't go forever on the left side. Okay. Then the domain of this function is all positive real numbers, all positive integers, or x greater than or equal to 0, or x greater than or equal to -1. So it's important to know what the domain of this function is, and what domain means. It's the domain. Well, definitely do this problem on your own and look at this very suspiciously is my hint. That should allow you to eliminate choices. In fact, process of elimination might actually give you the answer. So definitely try it on your own, see what you get. So here's one thing I see: all positive real numbers, all positive integers, all x greater than or equal to 0, or x greater than or equal to -1. So here's the thing: positive integers, this is defined on way more than the integers. I mean, look at x equals like -1/2. Go up, there's a point on the graph. So it's defined at x equals -1/2. X equals 3.14 pi. Around here, go up to the point, go up to the graph, there's a point on the graph. So it's defined at those numbers. It's defined everywhere, in fact, in between any square, especially on the right. So it's not that. Now, all positive real numbers, it's asking what the domain is. So if it's all positive real numbers, it means that it's defined there and nowhere else. So all positive real numbers, it means that it's defined at all positive real numbers, but not defined at 0 and not defined for any negative numbers. But at 0, I go up and there's a point on the graph. I go to the negative numbers, I go up and there's a point on the graph for some negative numbers, so that's not it. For x greater than or equal to 0, this means that it's defined at 0 and all positive real numbers, but not below it, which means no negative numbers. But if I go to like -1/2 or -1, I go to the graph. And there it is. That there's some negative numbers where the function is defined, so it's not x equals greater than or equal to 0. So it is x greater than or equal to -1. As a challenge, I invite you to think about what the actual equation for this absolute value function is. My hint is that it is an absolute value function, but it's on a restricted domain for x greater than or equal to -1, but it's still an absolute value function. Put in the comments below what you think the function is. Número 18, number 18. Which pair of equations would have -1, 2 as a solution? Y equals x plus 3 and y equals 2 to the power of x, or y equals x minus 1 and y equals 2x, or y equals x squared minus 3x minus 2 and y equals 4x plus 6, or 2x plus 3y equals negative 4 and y equals negative 1 half x minus 3 halves. Definitely try the problem on your own. This is a problem that you might find that you could do on your own. I mean, there's no reason to think that you couldn't. If you might feel like you can't, but you have to have some intuition on this problem. You do, no matter what your skill level is. No matter, I haven't had a student in life, and I've had all levels of student. You have never had a level of student in life that didn't have enough ability to answer something about this equation. Not at this level. So let's see if we can get the answer ourselves. But again, try it on your own. How do I do this question? I plug in x equals negative 1 and see if I get 2. Sounds good. So I plug in x equals negative 1. I get 2? Y equals negative 1 plus 2. This one's good. And next one, I plug in 2 to the negative 1. So 2 to the negative 1 is actually 1 over 2. Okay? Which is not equal to 2. So this is not it. This one, let's see, negative 1, 2. Choice 2. So y equals negative 1 minus 1 is negative 2, not 2. Okay, done, not it. The next one, I'm gonna plug into the linear equation to see, because this one's harder. Smart thing to do. Y equals 4x plus 6, when x equals negative 1. 4 times negative 1 is negative 4, and negative 4 plus 6 is 2, so this one looks good so far. So now I am gonna plug into the quadratic equation. I think these are a little bit weird with fractions and with things on the left. So I'm going to plug into this one. So I'm going to see y equals x squared minus 3x minus 2. And it allows you to see what I do with that negative 1. The pesky negative 1 causes a lot of students to get this question wrong. If you listen to what I'm saying, you'll get the question right and actually elevates your score relative to other students. So 2 is equal to x is negative 1. Negative 1 squared. Notice I put the negative 1 in parentheses. The parentheses are necessary. It's not optional. It's not us being pedantic. They're required. If you don't put the negative 1, it's actually wrong. Okay, so negative 1 squared minus 3 times negative 1 minus 2. And this is a multiplication of a negative number and a subtraction of a positive number, so that's going to also have some operations. So negative 1 squared is positive 1 minus 3 times negative 2. Negative 1 is negative 3, which is 3, so plus 3 minus 2. So 1 plus 3 is 4 minus 2, which is equal to 2. 2 equals 2. Definitely right. So it is choice 3, and therefore we can eliminate choice 4. I had a feeling that it wasn't going to be 4 because I see so many, this negative sign overpowering this negative, whether this was positive or negative. This one would satisfy the point. But this one, again, the negative 3 halves overpowers the expression on the right, and this becomes negative. Número 19, number 19. Which function could be used to represent the sequence 8, 20, 50, 125, 312.5, comma, given ... given that a equals 8. So I know, so these are some expressions. Let's actually establish some things about these expressions. Let's see if we could actually say something about them. I noticed that this increases by 12, then by 30, then by a bigger number, then by an even bigger number. So this sequence is not linear. Okay, so it's not an arithmetic sequence. And choice 1, an equals an minus 1 plus a1. This might not seem like a arithmetic sequence, but remember that an arithmetic sequence can be written as a recursively defined sequence as in terms of previous elements. So an equals an minus 1, so previous term, plus a1. Now a1 is 8. It's a fixed constant plus constant. Okay, so this in fact is arithmetic, also called linear. Okay. So it's not choice 1 because this does not grow linearly. It doesn't grow by the same number each step. So it could be exponential. Now this one is an exponential sequence, and I know this one because it's the previous term multiplied by a fixed number. This one is a previous term multiplied by a fixed number. Look at choice 3. It's a previous term multiplied by a fixed number and then plus another number. So this is actually not even, it's not arithmetic, nor is it exponential. It's something else. Okay. So which one of it is this? So I think the only way to do this is to evaluate now the expressions. So I have a feeling it's going to be this one. Let me tell you why I'm going to eliminate choice 4 before I even evaluate it. This says an equals a1 times an minus 1. So this is an is equal to, this is an 8 equals 8 times an minus 1. So in other words, take the previous term, multiply it by 8, which is a big number. 8. The next one would be 8 times 8 is 64, which is not 20. The next one, just to check again, the second term times 8 would be the third term. 20 times 8 though is 160, not 50. Well, not the number 50, so it's not this one. So it's either choice 3 or choice 2 by process of elimination. Let's test choice 2. A2 is equal to 2.5 times A1. Let's see, equals 2.5 times 8, which equals 20. Good. A3 equals 2.5 times A2, and so this one works out, equals 2.5 times 20, which is equal to 50. So this one is looking good. I suspect that this is the answer. If we keep going, we'll be able to verify. Now let's test this one to see if this is the answer, because I suspect that they chose the numbers right so that the first term would work, to see if a student would look at the first one, go from 8 to 20, realize it works, and done. And in fact, it's like 8 times 1.5 is 12, plus 8 is 20. 20 times 1.5 is 30, but plus 8 is not 30, is 38, is not 50. So this is not the answer. So so this one would go 8, comma 20. The next one is again 20 times 1.5 is 30, plus 8, okay, is 38, not 50. So this is not the answer, so it is choice 2. How cool is that? Numero 20, number 20. The formula for electrical power, if you know your physics, is P equals I squared R. Don't be scared. This is an algebra test. They don't expect you to know this, what each thing is. They'll tell you what they are. Where I is current and R is resistance. Electrical power P, I is current, R is resistance. The formula for I in terms of P and R is I equals P over R squared, I equals radical P over R, I equals P minus R squared, or I equals radical P minus R. Definitely try this problem on your own. This is what I'll tell you. I have a lot of students who can solve equations, in fact, equations with some more complicated numbers, but the moment you add numbers that are a little bit too complicated, they start to fail at solving the equations. And I'm going to tell you the exact reason why. I'm talking about like this, for example, 2.3, like, 2.3, let me scroll down so I don't have to hide my face again. 2.3x plus 8.4 equals 1.7. And a lot of students don't know how to solve this equation, but if I told them 2x plus 8 equals 1, they would know how to solve this equation. And then I realized they don't really know how to solve the equation. They've just done the steps so frequently that they just kind of follow the steps like they always have. The truth is, if they knew how to solve the equation, they would be able to do the first one that I did, the 2.3x plus 8.4 equals 1.7. So I'm actually, in an effort to explain number 20, I'm going to solve this equation. I subtract 8.4 minus 8.4 minus 8.4, and I get 2.3x is equal to, well, whatever 1.7 minus 8.4 is. So 8.4, 7.4, 6.4, 6.7. So negative 6.7, and then divided by 2.3. Divide by 2.3, and I get x is equal to, I guess I'm gonna have to hide my face, whatever this happens to be, negative 67 over 23, which is an ugly number, but let's see if you know why I said that if they know how to solve the first equation, they should know how to solve this one, like if they truly did. Look at this. 2x plus 8 equals 1 minus 8 minus 8. 2x equals negative 7. Divide by 2. Divide by 2. X is equal to negative 7 over 2. If you look at this question, the way to solve this equation is by performing the inverse operation with the same number that's written. It wasn't the numbers that told you what to do. It never is the numbers that tell you how to solve an equation. It never is. It's the operation. It's always the operation that tells you how to solve the equation, never the numbers. So I saw a student see a 2.3 and an 8.4 and 1.7. They're like, oh my, I don't know what to do. The operation is what you do. You invert the operation. Do you see a plus? I don't care that it's an 8.4. Invert the plus with a minus. I don't care that it's a 2.3. That's a multiplication between the 2.3 and the x. Invert the times by dividing, and you get the answer. It's the same thing on the left side, and it's the same thing on the right side. That said, that's exactly what we're doing in this question. We're solving for I in terms of P and R. Look at this. See, if you think you got what I just said, this is clutch right here. Try to get the question right. See if right now, I don't care what level you are. I don't care if you think you're horrible at math, if you think you're great at math. I know a lot of kids who are great at math who can't do this question. And I know a lot of kids who struggle in math that I tell them what I just told you and they can do this. So pause, try the problem, all right? Cool, let me do this. I hope you tried it. So I'm gonna invert operations. I don't care that they're letters. They're letters, but it's not about the letters, it's about the operations. And I know operations. If they're letters next to each other, multiplication. If there's a square, that's a squaring, that's a power. So I'm gonna invert those. So I need to solve for R, for I, P equals I squared R, according to my order of operations, PEMDAS, which starts with a G, grouping symbols, right? Parentheses, but also any other grouping symbol. Okay, there is no parentheses, there's no grouping symbol, so I'm gonna, and I'm inverting operations, in fact, so I'm actually going backwards. When you invert operations, you invert them in the inverse order. I is by itself here, but it's being squared, and then it's being multiplied by R, okay? I need to invert R. I need to invert the multiplication by R, not because there's an R, but because there's a multiplication. Get what I'm saying? I need to invert the multiplication. It could have been a Q, a P, a W, a radical 2, a 8.4, 5.7. This is a multiplication. I need to divide. Divide by R. Divide by R. And I get I squared is equal to P over R. And now I is all by itself except for that pesky square. And I know how to invert a square because I know the inverse operation of a squaring operation. The inverse operation of a squaring operation is the square root operation. It doesn't matter that that's an I and that the left side are letters. And there's some division there. This is the squaring operation. I invert that with a square root operation. Okay, that's in fact the definition of the square root. It's the inversion of the squaring operation. So I is equal to radical P over R. Here's choice 2. That's it. If I wanted to do some elimination, by the way, I see a subtraction here, a subtraction here. There's not going to be any subtraction, so it's not going to be this or this. That's it. I really love number 20, but let's move on to number 21. The function f of x, q of x, and p of x are shown below. So I see f of x is this graph over here. I see q of x is this expression, and I see p of x is this table function. So when the input is 4, which functions have the same output value? So 2 of them are going to have the same output value at least, and possibly all 3. F and Q, F and P, Q and P, or F, Q, and P. So let's see. I think the only way to really do this is to evaluate the functions, and I think evaluating the easiest ones is easier. So I'm going to evaluate the easier ones. I noticed that 3 out of the 4 contain F. So if I happen to evaluate F and F is not, doesn't match any of the others, then I know immediately that choice 1, 2, or 4 and 4 are going to be eliminated. So let's see, f of 4. So f of 4. I need f of 4. So I need 1, 2, 3, 4. Okay, so I'm gonna go up here, here, and I'm gonna go to the right to find f of 4. So this is 4, and this is f of 4, which equals 3. Okay? Now I go to, I think p of x is the easiest to evaluate at x equals 4 because I could just read it. Okay? And then I see that that p of 4 is equal to 3. Okay? So any choice that contains f of x and p of x could be right, and if it doesn't contain f of x and p of x, it's wrong. So q of x is wrong, and q and p is wrong, and also f and q is wrong because it doesn't contain p. This one doesn't contain f, and this one doesn't contain p. So it's either f and p or f, q, and p. So I wish they gave it to us for free and we didn't have to evaluate q, but we do. So let's do that. Q of 4 is equal to, after a careful order of operations, PEMDAS, which starts with P stands for grouping symbols, right? PING symbols. PEMDAS, EMDAS. Hey, why do I put the M and the D next to each other and the A and the S next to each other? Tell me in the comments, see if you know, for a thumbs up. And so Q of 4 is equal to x minus 1 squared minus 6. So 4 minus 1 squared minus 6. 4 minus 1 is 3. 3 squared minus 6. And because I did parentheses, grouping symbols first. Then exponents, 3 squared is 9 minus 6. And 9 minus 6 is equal to 3. So it's all of them. How cool is that? Done. Número 22, number 22. Using the substitution method, Vito is solving the following system of equations algebraically. Substitution method. Okay, y plus 3x equals negative 4, and 2x minus 3y equals negative 21. Which equivalent equation could Vito use? The choice, let's see. There's some complicated ones. Let's see, 2 times negative 3x minus 4 plus 3x equals. I think the important thing to do is to think about how they did this question. They did this question by the substitution method, right? So that means that they substituted something from one equation into the other equation. Normally in the substitution method, you just pick one of the equations, solve for one of the variables in terms of the other variables. You're not going to get a numerical answer, but you're going to get an expression for one variable in terms of the other, and then you're going to take that expression and plug it into the other equation. If Vito is a smart kid, he would actually choose the first equation and solve for y. Why? Because this one has a 3, so we divide things by 3 and introduce fractions. This one has a 2, and none of these numbers are divisible by 2, so we'd introduce fractions by solving for x. This one has a 3. This is divisible by 3, but this one is not, so we'd introduce fractions again by solving for y in this case. So the first one is the one that's easiest to solve for y in terms of x. So y plus 3x equals negative 4. I'm going to subtract 3x. I'm going to subtract 3x on both sides, and I get y equals negative 3x minus 4, right? Okay, and then on the second one, I need to replace y, substitute y with this known expression. Let's see what I get, and let's see if it's one of the choices. I hope it is, because I don't know if it's gonna be. That's the truth, because when it's substitution, you're kind of guessing at which one they might do. So 2x, but this is the most logical one. If I were doing this problem, I wouldn't do any other substitution. So minus 3, y is equal to negative 3x minus 4. So negative 3x minus 4 equals negative 21. Let's see if this is one of the choices. Look at it. 2x minus 3 times negative 3x minus 4 equals negative 21. This is choice 3. Choice 4 is here for the students that kind of shifted the 3x to the other side, and there is no moving operation. Moving is not an operation, subtracting is an operation. That's why you get the minus sign. So it's not this one, it's not this one, it's not this one. Número 20. Wait, did the lighting change? Oh, my shirt changed too. It must be a new day. When you're recording videos in general, it takes a lot longer to record them than to actually watch them. This is actually day 3 for me. Number 23, materials A and B decay over time. The function for the amount of material A is A of t equals 1,000 times 0.5 times to the power of 2t, and for the amount of material B is B of t equals 1,000 times 0.25 to the power of t, where t represents time in days. On which day will the amount of material be equal? Initial day only, day 2 only, day 5 only, or every day? Okay, I mean, try the problem on your own, see what you get. There's a lot of ways of doing this problem, graphically, numerically, and if you actually know your exponents, I think you could actually get this question immediately. I suspect, so if I plug in 0, so the initial day only, so the time t equals 0, so I got A of 0 is equal to 1,000 times 0.5 to the power of 2 times 0, and then you do need to know that any number to the 0 power is 1, so this is 1. So this is 1,000 times 1 is 1,000. And then B of 0 is 1,000 times 0.25 to the power of 0. And again, any number to the 0 power is equal to 1. So this is 1,000 times 1, which is also 1,000. Okay, so the initial day, the numbers are the same. So this eliminates day 2 only, and it eliminates day 5 only. It leaves the initial day only or every day. Now we have a 50% chance of getting it right, and that's something that you should know, that any number to the 0 power is equal to 1. They do test on that. They do test to see if you think that it's actually equal to 0. Any number to the 0 power is 0. It's not. It's not. Any number to the 0 power is 1. So now we're left with a 50-50 chance of getting it right just from basic exponent rules. Super basic exponent rules. Now for the more complicated stuff. You could graph these. That's a great way of doing these. If you graph this one, remember the trick I taught you, graph it with a bold line, graph this one with a regular line, you might see that they do or do not overlap. If they don't overlap, then it's 1. If they do overlap completely, it's every day. So I'm going to do this algebraically, so using my exponent rule so that I can give you a little bit of a review. A of t is 1,000 times 0.5 to the power of 2t. The exponent, it's also equal to, so the rule for exponents is that I'm going to use here is that if a base is taken to 2 different powers, it's equivalent to taking it to a power and then to another power. Normally this rule is useful in the reverse direction. That's cool if you want to erase what I just wrote. 0.5 to the power of 2, and then that to the power of t. Normally we use this rule to combine exponents, but in this case we're going to use it to split exponents, and this is equal to 1,000. 0.5 to the second power is 0.5 times 0.5 is 0.25. 0.25 to the power of t, which is actually the exact expression for b of t. So not only are they equal to each other every day, but we've confirmed that they can be simplified to the same expression. So it's every day. Número 24, number 24. The following conversion was done correctly. So we know the conversion is correct. We assume it. 3 miles over 1 hour times 1 hour over 60 minutes times 5,280 feet over 1 mile times 12 inches to 1 foot over 1 foot. What are the final units for this conversion? Minutes per foot, minutes per inch, feet per minute, or inches per minute. So definitely try the problem on your own. This is not that tough if you really just think about what you do know about fractions, and you're shortchanging yourself if you think you know nothing or not enough about fractions. I think you know enough. So try it on your own. This is what I see. I see this is a conversion. So this is converting the original amount to different units. The numerator of this one is miles. The denominator of this one is hours, so a distance over time. These are times, these are distances, and these are distances. So the units are gonna be distance over time. So that eliminates this one, and it leaves feet per minute or inches per minute. So now we have a 50-50 chance of getting it right. Now, what we do for this one is we know the rule of how multiplying fractions works. Multiplying fractions is the one, students confuse adding fractions because they think it should be as easy as adding horizontally. It's not. You have to do maybe crisscross bottom or getting a common denominator. But multiplying fractions is done that way. You multiply horizontally. So multiply this way, okay? And multiply this way. Now, there's a corollary to that. The corollary to that is that if you have a factor in the numerator and a factor in the denominator, factors, they're multiplied, then they cancel. So the hour in the denominator cancels the hour in the numerator. This, let's see, minute does not cancel with anything. Mile in the denominator cancels mile in the numerator, okay? And then feet in the denominator cancel feet in the numerator, okay? And then those are the units. Inches does not cancel. So we're left with minutes in the denominator, inches in the numerator, inches per minute. Inches per minute. It's number 4, so it's not number 3. Numero 25, number 25. Solve algebraically for x. 3600 plus 1.02x is less than 2000 plus 1.04x. So talk about the ACTs. The ACTs does not have any fill in the blank questions, but if you're taking the ACTs, chances are you're going to take the SATs too. And the SATs do have fill in the blanks. I don't know if you know that. The fill in the blanks are not long answers. The fill in the blank is just give the answer. And the relevant thing is that that actually makes it harder, not easier. The New York State Regents does grade with partial credit, but the SAT does not grade with partial credit. And then on the ACTs, it's a multiple choice question. But either way, you really have to know how to solve these algebraically in order to be able to get the answer anyway. There are tricks with multiple choice that you can use, like testing the endpoints. And testing in between. But besides that, knowing the method for more difficult problems is going to become relevant. Now, how to do this one? It does say algebraically for this Regents. If you're from New York, it does say algebraically. So a numerical method does not work. Algebraically means, inverse operations, combining like terms. If you have a distributive property, those kinds of things. That's how you get this answer. But it has to be through performing inverse operations, basically. So I need to get x by itself and usually I get it on the left. And so I'm gonna get x on the left. So you might not like that I get a negative number, 1.04x minus 1.04x. And then, so I get 3600. 1.02 minus 1.04 is minus 0.02x is less than 2000. And you might not like, again, that I get a negative number in front of the x, but usually students get confused when they do inequalities or even equations when x is not on the left. You shouldn't. I do think you shouldn't, but at the same time, since students try so hard to get the x on the left and then they get confused when they have to get it on the left and it's already on the right, I'm going to get it on the left, even if it's a negative number. I subtract 3600. And then what do I get? I can use a calculator here, so I get negative 0.02x is less than negative 1600. And if you don't know that, you should use a calculator. You should do 2000 minus 3600. And subtracting to get a negative number is another place that students super get wrong, even students who are in the 90s and 95s. So if these numbers confuse you, you should get used to them. But if you're not used to them, use the calculator. Okay, so now I need to divide by negative 0.02. Another place where students get things wrong is where they add 0.02 because they see a negative sign, forgetting that it's not the negative sign, it's not the number that tells you what to do, it's the operation. This is a multiplication right here, so we need to divide. So we do need to divide by negative 0.02. Divide by negative 0.02. And now another place, the final place where students get confused is that since they're dividing by a negative number, so they're dividing by negative 0.02, that actually flips the direction of the inequality. So this becomes a greater than. And now 1600 divided by 0.02, I do know the answer. 16 divided by 2 is 8. Move the decimal place over twice. And then also a negative divided by a negative is a positive. But if you don't know that, negative 1600 divided by negative 0.02. Okay, There it is, 80,000, positive 80,000. And that's another place where students get things wrong. A negative divided by a negative somehow becomes a negative. It's not, it's a positive. Negative divided by a negative is a positive 80,000. And that's a full 2 credit answer. And it's actually not that long of a process, is it? I would recommend that you do this on your own. See if you did this on your own, you could see where you got it wrong. Correct that error for future problems. Número 26, number 26. All right, these problems are getting wider. Let me just shrink myself and up. All right, the number of people who attended a school's last 6 basketball games increased as the team neared the state's sectional games. This table below shows the data. Game on top, 1340 to 18, okay, attendance 348, so a bunch of numbers in the mid-hundreds. State the type of function that best fits the data. Justify your choice of a function type. So this is a interesting problem that they like to give now. They've been recently given this one, so definitely understand where this answer is coming from, all right? There's 2 types of functions that they're really going to ask for, linear or exponential. The reason there's really only 2 types that they're going to ask for is that once you start going for the curved functions, you have to have a lot more data points before you can differentiate between an exponential function and a quadratic function, for example. It's really too tough, too many points. So they're really only going to ask for linear or exponential. So here, what we're going to do is we're going to calculate the first difference. And that's the way to do it, the first difference or the first ratio. If the first difference is constant, then the first ratio, then it's linear. If the first ratio is constant on the y-axis, then the function is exponential. So 1, 1. So we know that these are growing linearly, okay? So these should be growing linearly if this function is a linear. So 348 minus 435, okay, and we do need the calculator, so 4 on 435 minus 348, okay, 87, okay, so then 522 minus 435, 87. Looking good so far. 522 minus 605, so 609, I'm sorry, minus 522. Ugh. Ah, 87. And if in fact I see what 87 plus 609 is, this in fact 696, so this is 87 as well. And 596 plus 80 is 776, okay? And 776 plus 7 is 783, so in fact this is 87, okay? So, state the type of function that the data justify its full choice of a function type. The function type is linear. And don't skip the problem after I'm done writing, because there's something extremely important that needs to be said, because the first difference is constant. Okay, so the very extremely important things that needs to be said is that this first difference didn't have to be exactly constant for this problem, and it wouldn't have been a trick question. It could have been, the first difference could have been 87, 86, 88, 85, 89, 88. That's still fairly constant. It's almost exactly constant, and this answer would have still been linear because the first difference is almost constant. On the other side of it, if you got the first difference not being constant, and then you calculated the first ratio, 435 over 348, 522 over 435, and you calculated whatever the numbers were, and you calculated the first ratio. So instead of subtracting them, you divided them, and you got it nearly a constant, then that would have been an exponential function, and the function type would have been exponential because the first ratio is nearly constant. That's not a trick question. They really can ask that, and it's actually a completely fair question on an ACT, SAT, or Regents. And on the Algebra 2, they will ask that way. Número 27, number 27. Solve for x squared minus 8x minus 9 equals 0 algebraically. Explain the first step that you used to solve the given equation. So things to know, if you're taking the SAT or ACT, they don't care about the method, they just care about the answer. So if you know the quadratic formula, for example, if you want to do it that way, you could do it that way. If you want to do guess and check on the SAT or ACT, you could do that. In fact, this one might not even be that hard to guess and check. If the thing is that those don't count as algebraic methods for the purposes of this test. So they count as numerical method. The quadratic formula and guessing and checking both count as numerical methods, not algebraic methods. I don't agree with that, but that's the case. So how do we do this one? There's two ways of doing it algebraically that I know of. There's many more. One is finding two numbers that add up to -8 and the same two numbers whose product is -9. Use those to factor x squared minus 8x minus 9 as two factors, and then solve from there using the zero product property. That's one. The other one is completing the square. Completing the square I think is a little bit harder, but the test loves to ask about completing the square, and we haven't really gotten to practice completing the square on this test yet. So I'm going to actually do this one by that method, completing the square. Pay attention to the way I do this, because every completing the square problem is exactly the same. 100% of them exactly the same if a is equal to 1. Every single one, the same steps. So the first thing we're going to do is we're going to isolate x squared minus 8x minus 9. We're going to isolate the terms that have an x by adding 9 to both sides. Okay? And then x squared minus 8x equals 9. Now I highly recommend this part. Some students try to skip this writing, but there's a reason why I want you to write this. Write the value of b, -8. Write the value of b over 2 equals -4, and write the value of b over 2 squared equals 16. Why are we doing this? Because these two numbers, not just the one of them, but these two numbers are the exact values that are going to allow you to complete the square on the left. There's one unique way of completing the square on the left. These are the numbers that we're going to use. So first we're going to add b over 2 squared to both sides, so plus 16, and we get x squared minus 8x plus 16 equals 25. Okay. Why do we do that? Because this now, so we use 16, now we're going to use -4. This adding 16 is the exact number, the only number, the unique number that allows us to complete the square on the left side. And how do we complete the square? It's using this number. So it's x minus 4 squared. This is the unique way of factoring the left side as a perfect square, 25. Okay, so that's why these numbers are extremely important. Okay, so now that on the left side, the variable appears exactly once, so we could actually solve this equation using the inverse operation method. Invert all the operations in the inverse order that they were performed, and using the inverse operation. So first -4 was subtracted, and then 4 was subtracted, and then the squaring operation was performed. We invert the last operation, the squaring operation, with the square root operation. Okay, this is exactly the place where a lot of students mess up, because the squaring operation is an information destroyer. The squaring operation destroys the information about whether the original number was positive or negative. So by taking the square, when we take the square root, we have to consider both cases, if the number was negative originally or if the number was positive originally. So we get x minus 4 is equal to plus or minus 5. Okay, now we just add 4 to both sides to isolate the x, plus 4, and we get x is equal to 4 plus or minus 5 equals, in other words, 4 plus 5 or 4 minus 5, which simplifies as 9, or 4 minus 5 is -1. Let's check our answer. Okay. If you want to check, I would advise you to use the positive number if you're not comfortable with negative numbers. I'm going to actually use the negative one to give you practice with negative numbers. So -1 squared minus 8 times -1 minus 9 equals 0. -1 squared is a positive 1, not a negative 1. Minus 8 times -1 is plus 8. and then minus 9 equals 0, and this should have a question mark here. 1 plus 8 is 9, and minus 9 equals 0. You might think it's obvious that this is 0, but you don't stop until the left side expression is exactly the same as the right side expression. 0 on the left, 0 on the right, done. So this is right. Notice I'm not checking the other number, the 9. If you're doing a quadratic equation problem and if you just check one of the numbers and that one happened to work, generally the answer is correct. The reason is that if you made a mistake at any point in the process of solving this equation, you usually would get both answers wrong. One of the answers is right, so most likely both answers are right. So that's not a hard and fast fact. Most likely it's true. If you want to check the other number, you can, but remember that sometimes time is a factor. On the ACT and SAT, time is an extreme factor, and then on the Regents, it can be a factor depending on you. Now, the second part, explain the first step you used to solve this equation. That's this plus 9 over here that we added. We added 9 to both sides of the equation to isolate the x squared and x term. X squared and x term in order to complete the square. Okay. Numero 28, number 28. The graph of f of t models the height in feet that a bee is flying above the ground with respect to the time it traveled in t seconds. Okay, the height above the ground with respect to the time. So height in feet, I see 2 and 4 feet, and I see 2, 4, 6, 8, 10, 12, 14. Time in seconds, and I see a jagged line. And so it goes. It looks like the bee is going up and down. I don't look at the graph more thoroughly than that until later, but I do take a quick glance because it helps me understand the problem better. State all the time intervals where the bee's rate of change is 0 feet per second. Explain your reasoning. Okay, so rate of change. If you don't know how to do this problem, if you don't know what the rate of change is, and we need the rate of change to be 0. Okay, so what is the rate of change in this case, since it's a height and a time? I haven't looked more at the graph yet. So the rate of change is equal to the change in the height divided by the change in time for any sub-interval, for any interval or any sub-interval. So is equal to height final minus height initial divided by t final minus t initial. Okay. So in this case, notice that for this to be 0, it means that this fraction has to be 0. So we need this to be 0, which means that the height final is equal to the height initial. Okay, so now we look at the graph a little bit more thoroughly. This graph is representing the bee's height over time. So following this graph, it's going up, which means the bee is actually going up from 0 feet to 1 feet over 2 seconds. Then it kind of stays there at the same level. That's the rate of change. So the height is not changing, so the rate of change of the height is 0. This slope is positive. In other words, the function is increasing over time. So the rate of change is positive. The slope is positive, the rate of change is positive. Real quick, easy way to see it. Then all of a sudden the bee starts stopping. The rate of change is negative. And then the rate of change is suddenly positive again. And then the rate of change is flat. Okay, and it says explain your reasoning, right? So we're gonna say the rate of change. So let's put that there, okay? Change. See, these are notes for you. This is not part of the problem. You do need to know this, but you could put this on your test, and in fact, you probably should. So the rate of change is 0, okay? So the height is not increasing, okay? And the slope is 0. Okay? So that's the explanation. There we go. And in explanation, we need words. Okay? If it says justify needs words. No, explain needs words, and justify needs anything, algebra or words. Okay? But where you explain does require words. So the slope is 0. Okay? The slope is 0. On the interval, let's see, 2 to 6, and on the interval, let's see, time 14 to 15. So these are the two intervals, 14 to 15. Okay, you might have written it as this. T such that 2 less than or equal to t less than or equal to 6, or 14 less than or equal to t less than or equal to 15. Okay? Either one of these answers would have been correct. Okay? That's it. Numero 29, number 29. Graph the function f of x equals 2 to the x minus 7 on the set of axes below. Nice set of axes. And if g of x equals 1.5x minus 3, determine if f of x is greater than g of x when x is equal to 4. Justify your answer. I see the word justify. Justify requires some algebra or numerical justification, but does not require words. But we do have to justify it. Explain requires words. So first we graph the function f of x equals 2 to the x minus 7. So just numerically speaking, I see that 2 to the x, this is a base greater than 1. So I know that this is going to be an increasing exponential function as x increases. And of course, 2 to the x for negative exponents gets closer and closer to 0. So when we subtract 7 from it, it's going to have an asymptote, a horizontal asymptote of negative 7. So it's, in other words, it's going to get flatter and flatter and flatter as x gets closer to negative 7. Now, here's a question. Do we have to label all the numbers negative 10 to 0 to 10 and also negative 10 to 0 to 10 upwards? We don't. The rule about labeling the graph is if you assume that each box represents one unit, you don't have to label it. However, if you want to expand the graph at all so that each box represents anything other than 1, you do have to label the boxes. So I'm going to use each box representing 1. So 1, 2, 3, and I don't have to label it. So I didn't even have to write this. I just want, this is me explaining what I'm doing. And of course, negative 1, negative 2, negative 3. So that negative 7 is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. That's over here. Okay, negative 7. And I'm going to make a dotted line here. Okay. Now you might not be liking that I'm not using a graphing calculator, but let's do that. I already know what it's going to look like though. Y equals, let's clear this, and this is y equals 2 to the power of x minus 7. And let's do zoom standard, 6. Look at it, it's kind of flat to the point where you think it's a line and then suddenly it blows up, right? That hockey stick effect is what an exponential function looks like. A hockey stick goes straight, but then it kind of curves on the bottom. So this is what we call a hockey stick effect. And exponential functions are hockey stick curves. It's a nice visual to let you remember that. Exponential functions are hockey sticks. Where was this asymptote? We said it's at y equals negative 7. In fact, it is. And if you need points to graph, the table will do that for you. You just have to make sure to remember to go to the table set. Make sure that table set is set to auto, and table start, you can put it at 0, and delta table is equal to 1. Putting the independent variable at ask is actually a really good tool, because if you put it at ask, you could choose the numbers that it tests, but then it's left blank and it won't give you any values until you test them. So it's giving me the values so that I can make it easier to graph. Let's see, 0, negative 6, 0, negative 6. Let's see, 1, negative 5. Okay. 2, negative 3. Notice it's hopping up by 2, then by 4. 3, 1. 4, 9, 4, 9, and then 5 and beyond are too big. 25, 57. Okay, big numbers, right? So now let's go back in the negative direction, and we should expect this to get closer to -7. So -6, let's see, -1, -6.5, -6.75, -6.875, 0.98. You see, it's getting closer and closer to -7. So we do in fact get an asymptote. So here, 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 and it's getting closer and closer, but it's not touching. So now we do a curve. Another place where students get points lost on this is that they connect the dots with straight lines. Only straight lines get connected with your very nice straight edge that you're required to be given on the New York State Algebra 1 Regents. But this is not a straight line, this is a curve. So I am using a curved arc, okay? And I'm connecting all the dots that I have, okay? And then with curve, okay? And then I put an arrow here because it's gonna keep blowing up, and I put an arrow here because it's gonna keep getting flatter. Okay, the second part, if g of x is equal to, and that's a point, that's a lot for a point, but it's a point. Here, if g of x is equal to 1.5x minus 3, determine if f of x is greater than g of x when x is equal to 4. Justify your answer. This is normally a 4-point question, but here it's a 3-point question. Here, if f of x is f of x greater than g of x when x equals 4, justify your answer. You don't have to graph this. You can, you're allowed. Any justification is allowed. So if you graph this and look at the graph to see where they're located, that's good enough. We're gonna do this algebraically, but I will graph it to check. Y equals, let's go 1.5x, 1.5x minus 3, and we're talking about when x is equal to 4. So we're gonna graph this. When x is equal to 4, and we could use the trace button. 1, 2, look at the x value, 3, 4, oops. So here's about 4. So the line is here, and the exponential function is higher. So that shows that the exponential function is higher. But let's actually do it by calculating, just so we're confirmed. What they're saying is f of 4, we're comparing it to g of 4. F of 4 is equal to 2 to the 4th minus 7, okay? Which is equal to 16 minus 7, which is equal to 9, okay? And then let's scroll down a little bit. Let's see, and g of 4 is equal to 1.5 times 4 minus 3, which is equal to 6 minus 3, which is equal to 3. So f of 4 is greater than g of 4. Yes. Okay. There is no verbal explanation that needed. We showed algebraic justification, and that justification does not require words. So does not require words. Explanation requires words, justification doesn't. Numero 30, number 30. Determine algebraically the zeros of f of x equals 3x cubed plus 21x squared plus 36x. This says algebraically. I know a lot of people are fans of the quadratic formula. Quadratic formula counts as a numeric method, so we can't use it here. And guessing and checking counts as a numerical method. Again, we can't use it here. So we have to use factoring, our usual methods, either the AC method or the BC method, or completing the square. I did one a couple of steps above, which I completed the square. So we will do this by the other method, the AC method, because the AB method, the BC method, because we can. So let's see. So what we need to do is find the zeros of this. In other words, they want us to find 3x cubed plus 21x squared plus 36x. equals 0. Now, some eagle-eyed members of you might have noticed that this number is equal to 3, this is 21, and this is 36. So they have a common factor of 3, right? So, and they have a common factor of x, and we should factor those out. So 3x, and it makes it easier for us. I wish they didn't make it quite this easy for us, because it would have allowed us to practice something else, and they just gave us this problem earlier. So it's a repeat of the question. There's a rumor that this current version of the Algebra 1 Regents is going to disappear soon. Soon meaning 5 years, unfortunately for you guys. But what it means is usually when that starts to happen, the quality of the test starts to go down. I think they just maybe have fewer people working on this test, and they just gave us a quadratic formula problem where a is not equal to 1, or a factoring method, I'm sorry, where a is not equal to 1, and they wanted it algebraically too. So they're actually repeating the same skill. But factor out of 3x times x squared plus 7x plus 12 parentheses equals 0. Now the other one I did by completing the square, so I'm going to do this one by the BC method. So blank plus blank, two mystery numbers equals 7, and the product of those same two numbers is equal to 12. Okay, now how do I find these numbers? I teach kids to do the factor rainbow. One is this is a method of writing the numbers that I learned from a student actually. 1 and times 12 is 12. Go to the next number. 2 times 6 is 12. 3 a factor of 12? Yes. 3 times 4 is 12. And then the next number is 4, but 4 is already on the list. We never have to skip anything. We're done. We found all the factor pairs of 12. One of these numbers, since this is positive and this is positive, two of these pairs have to add up. One of these pairs has to add up to 7. So 3 and 4. 3 and 4 is 7. 3 plus 4 is 7. So here it is, 3 and 4 and 3 and 4. So how do we use that? It turns out then 3x times parentheses equals 0. This quadratic expression factors as x plus 3 times x plus 4. These two numbers are the unique numbers that allow us to do it. That's what to do this to factor 3x squared plus 7x plus 12 as a factor of two monomials. So that's why we do it this way. Monic monomials with a coefficient of 1. So now we need to use the zero product property. A lot of students will stop and say the answers are 0, 3, and 4, and they're wrong, and immediately they lost a point. We have this step that teachers seem to take and we seem to think is unnecessary is necessary. The answers are not 0, 3, and 4. 3x equals 0. Divide by 3. Divide by 3. So x equals 0 is one of the solutions. But the next one, x plus 3 equals 0. Another thing that students do is like move the 3 over. That's not an operation. Moving a number over to the other side of an equal sign is not an operation. It's like having a balanced scale, taking a gram off of one, putting it in the other, and thinking it's going to stay there. It's not, right? So minus 3. So we're actually taking away 3 from both sides, and we get x is equal to negative 3. Okay. And then also x plus 4 equals 0, minus 4, and we got x is equal to negative 4. And these are the 3 answers, and we're done with this problem. Numero 31, number 31. Santina is considering a vacation and has obtained high temperature data for the last 2 weeks for Miami and Los Angeles. So Miami, you have a whole bunch of temperatures, okay? And Los Angeles, we have a whole bunch of temperatures, cool. And then which location has the least variability in temperature? Explain how you arrived at your answer. Okay, so before we even start this problem, we do need to understand that this variability can be interpreted in 2 different ways. One is the standard deviation, and if you don't know what that is, then the calculator does calculate it for you, but it's a measure of how spread out the data is. Okay, and then number 2 is just the max minus the min. And the truth is that there's other ones, Q3 minus Q1, okay? But we're gonna focus especially on these two, because if the standard deviation for them happens to be the same, then we need to go to max minus min. Let's go to the calculator though. We do need the calculator to determine these numbers. So we go to stat, press the stat button, and then we see the first thing that says edit. That's the edit button to go into the lists. I've actually typed in both lists very carefully into this problem. I've already typed the data in just to save us a little bit of time. One of the things that I advise you to do is it's really easy to accidentally mistype a number. So definitely check that you typed all the numbers correctly. I just did check that and I typed them all correctly. So now what I'm gonna go to do now, I'm gonna go to the catalog. Okay, this is an extremely necessary thing to do. For some reason, diagnostics is not usually turned on calculators. Diagnostics really should be automatic. I mean, the diagnostics tell you a lot of information about the data. So let's go to diagnostics on. It should be the default. There's no reason to keep it off, in other words. In fact, there's just no reason to have it off. I don't think off or on should even be an option on these calculators, but it is, and it's usually off, so we have to remember to turn it on as students, okay? So now diagnostics is on. So now I'm gonna go to calc, one variable statistics, okay? Because each one of these is separate from the other. One variable statistics, list one. Frequency list, there is no frequency list. Calculate, okay? So looking at these, so here's the sum. Here's the first one is the average, the second one is the sum, the third one is the sum of the squares. Those are relevant numbers. For the average, of course, is a very relevant number. The sum is relevant, the sum of the squares is relevant for other things. SX and sigma S. SX is the sample standard deviation, and sigma X is the population standard deviation. The difference between the concepts. This is not that important for this problem, but I will tell you for completeness sake. The SX, the sample standard deviation, it goes under the assumption that that this is only a sample of the full data. This sigma X it goes under the assumption that this is the entirety of the data, that there are no other days. So SX is the more relevant number for us. So for Miami, okay, SX is equal to 7.49 and then 7 and then a 9, which causes us to round up to 7. So 7.498. Okay, and we could even put sigma X if you want to just be complete, if you're nervous about which one. 7.225 and the next one was a 7.225. Okay, now let's keep going. The number of data points is 14, and then the min and the max. The min is 60, the Q1 is 75, median is 80, Q3 is 83, max is 87. So we're gonna do the max minus the min. So max minus the min is equal to 87 minus 60 is equal to 27. Okay, now let's go for Los Angeles. Okay, so SX equals sigma X equals, and let's scroll down here a little bit. Oh, I think that was a little bit too much. And then max minus min equals, okay. So stat, calculate one variable statistics, list is L2. L2 is right here above the blue, above the 2 button, it's in blue. So we press the blue second button, L2, enter. There is no frequency list. Frequency list tells you how frequently each data point occurs. Each data point occurs once because we put it that way. Calculate. So SX is 3.77 in this case. 3.77, and then the next one is a 6 and then a 7, so 7. The sigma X is 3.639. 3.639. I don't care, Samsung. And then max minus the min let's go to the max minus the min. So 74 minus 61. 74 minus 61 equals 13, okay? And notice that this number is smaller. And these numbers are actually also smaller, okay? So by both definitions, the standard deviation and the max minus min definition, the variability in Los Angeles' temperature is lower. So that's got to be the answer. If these were opposites, like this one was bigger, this one was smaller, you'd have to think a lot. That's rare for that to happen. You'd have to think which one you want to use as the definition, but they're not going to do that to you because since there's two definitions, they're not going to trick you into having to choose one versus the other. It's not meant to be a coin flip for the right answer. So the variability in temperature for Los Angeles is lower because the standard deviation deviation is smaller. That's it. All right, let's deviate to number 32, 32. Solve the quadratic equation below for the exact value of x. 4x squared minus 5 equals 75. I misread this problem multiple times and I said 4x squared minus 5x. So watch out for that. 4 times I misread. So, okay, let's move. So how do we solve this equation? You can actually do this by any method that you want, completing the square quadratic. It's already completed though, technically. You could use the quadratic formula. You can use numerical methods now because this one does not say that we have to use a specific method. I see that there isn't an x term. In fact, I see that x only appears once in the equation. So this one, I actually am going to do it using the inverse operation method. I think it's the easiest way to do it. We haven't used the quadratic formula yet, I know, but a lot of students get confused on the quadratic formula when there isn't an x term. I will note this if you do want to use the quadratic formula, okay? I will say this, that you get ax squared plus bx plus c equals 0. So you have to get 0 by itself. So you have to subtract 75. And then notice that there is no x term, b equals 0. Okay? That's where students get sidetracked a lot. So we're not going to use this method though because x only appears once. We're going to use the inverse operation method. So we're going to add 5. We're going to add 5 and we get 4x squared equals 80. Why did I do that first? Because x is being squared, then it's being multiplied by 4, and then 5 is being subtracted from that. The last operation performed is subtracting 5, so we're going to undo that as the first operation by adding 5. Now, the last operation performed on x is a multiplication by 4. We're going to undo that by dividing by 4. So we're going to divide by 4, we're going to divide by 4, and we're going to get x squared equals 80 divided by 4 is 20. Okay, and now we invert the squaring operation by the square root operation, okay, and we get, remember that the squaring operation is an information destroyer. We don't know if the original number was positive or if it was negative because the squaring operation destroys the sign. It turns the number positive. So unless the number was originally 0, then it just turns it to 0. So we do need to take into account both possibilities. X is actually equal to plus or minus radical 20. And this is worth a point already. This is not worth perfect 2 points. This is worth 1 point. Why? Because the radical 20 can be simplified, and they do expect us to simplify this by factoring out the biggest perfect square factor of 20. So equals plus or minus, and inside the radical, nothing comes out of the radical. There is no taking something out operation. That's never been an operation. If an operation is written, you do it. If an operation is not written, you probably don't have a reason to do it. So radical 4 is the biggest perfect square factor of 20 times radical 5, and 4 times 5 is 20. And now we don't take a 4 out of the radical, we don't take a 2 out of the radical, we perform the radical operation, square root operation. The square root of 4 is 2, so plus or minus 2 radical 5. Okay? And I'm not just being technical, that's where students lose points. Let's root ourselves in number 33. This is the first 4-point question. for us on this test. Marilyn collects old dolls. She purchased a doll for $450. Research shows that this doll's value will increase by 2.5% each year. Write an equation that determines the value V of the doll T years after purchase, and then assume that the doll's rate of appreciation remains the same. Will the doll's value be doubled in 20 years? Justify your reasoning. If I can make some quick estimates, which is what I advise you to do, if it increases by 2.5% each year, 2.5 times 20 is 50. Okay, so it's not that it's going to increase by 50%, but that is a fairly okay estimate. So 50% is quite far from 100, so I suspect that it's going to be close to 100, but not quite. Now that calculation that I did, 2.5 times 20 equals 50, that is actually always guaranteed to be an underestimate, so we do have to be careful. I just made an estimate, and I'm making the estimate not being 100% sure what the answer is going to be, so keep that in mind, that 2.5 times 20 is 50 is only an estimate for the growth. The growth is guaranteed to be more. So also the equation that they want you to know here is A equals P times 1 plus R to the power of T. In fact, I'm going to put the over N and the N here, T, where A is equal to final value, okay? P is equal to the principal, also known as initial value, okay? R is equal to the rate of increase. N is equal to the number of times compounded on a per year basis, okay? This number is only relevant when we're doing finances, like if you have an investment that grows at a certain number of times, compounded quarterly. Quarterly means 4 times per year. Semi-annually, twice a year. Monthly, there's 12 months in a year. Daily, there's 365 days in a year. Weekly, there's 52 weeks in a year. All right. So, and would be 52 in the case of weeks. But in this case, it's not being compounded at all because they don't say that it's being compounded. They would tell us how frequently it's compounded per year. Okay, but you do have to know things like compounded every quarter means that there's 4 quarters in a year, so that the N is 4. Or if it's monthly, you do need to know that there are 12 months in a year. That's common knowledge. Or that there are 365 days in a year. You do have to know these things. So N is not a relevant number for us. And then, of course, T equals time. And then for finances cases, it's in years. Okay. For non-finance cases, T could be in days, weeks, whatever it happens to be in the specific problem. And in non-finance cases, then N is guaranteed to be 1, so the equation simplifies a whole lot. So now write an equation, the value V. So V is the value, so in this case, A is V, and then P is, and it's an unknown value, it changes over time, but the initial value is 450, so P is 450. Okay, there's a 1, there's a plus. Now, 2.5% is, as a decimal, 0.025. You move the decimal place over twice. Okay, 0.025 over 1. We don't have to write the 1 because it's not a finance case. It's not a number times compounded. N is 1 again, same N here, and then T is unknown value T. T changes over time. So this is the equation for part 1 of this problem, so that's 2 points. Done. Let's scroll down a little bit here. Assuming the doll's rate of appreciation remains the same, will the doll's value be doubled in 20 years? Justify your reasoning. They said justify, numbers and calculations are enough. They didn't say explain. So 20 years, this means that T is equal to 20. We estimated that it would grow by 50%. But again, that's an underestimate. The actual estimate compared to the linear estimate is always higher. But 50% compared to more than double, which is more than 100%, That's a big jump. So let's see. I suspect the answer is going to be no. So V in 20 years, 450 times 1 plus 0.025 to the power of 20. And this is equal to, this is not something I can do on the in my head. I can maybe make an estimate to this in my head, but not good enough to answer this question. So 450 times 1 plus 0.025 to the power of 20. And let's see what this is. 737 and 37.7 cents. So 737 and 37 and 7 cents, so 38 cents. Okay. So now the percent growth is equal to final minus initial over initial times 100. Also equal to V minus P over P times 100. In this case, it's V minus P or A minus P over P times 100. So let's see. Final is 737.38 minus initial 450 over 450 times 100. I'm going to put parentheses around the numerator. I don't need to in this case, but I do need to in the calculator. Okay. So parentheses, because the diagonal fraction bar is not a grouping symbol, but the horizontal fraction bar is. So this fraction bar and this fraction bar are actually different. 737, in that one, this one is not a grouping symbol, but this one is. That's the only difference. 0.38 minus 450, and I can already tell that it didn't double. 900 is the doubling. So, but we do need to confirm. We do need to confirm algebraically. So times 100, and just saying it is not enough. So 63%. So this is 63.86. So 63.9%. 63.9% growth. Okay, and then we could say no. So no. The reason is that we do have to say yes or no. We don't have to give a verbal reasoning, explanation, because this is justify, not explain. But the reason is that this number is not 100%. You could say the value grew by 63.9%, which is less than 100%, so the price did not double. Numero 34, number 34. Again, another 4-point question. The data given in the table below shows some of the results of a study comparing the height of a certain breed of dog based upon its mass. So I see mass, and I see some numbers, and then I see height, and I see some numbers. Write a linear regression equation for these data, where x is the mass and y is the height. Round all values to the nearest tenth, and then to the nearest tenth. And you do have to round to the nearest tenth. If you don't round correctly, they'll take a point. If you don't round at all, they'll take a point. If you round to the nearest thousandth, they'll take a point. So definitely obey when they say to round to a fixed number, and then state the value of the correlation coefficient to the nearest tenth again, and explain what this indicates. Almost always this data will have a strong correlation. Almost always. For some reason on this test, they don't give data that has a low correlation. So let's see. We're gonna get the calculator, and this is a question that they love to ask. So you just follow the procedure, and it's 4 free points on this region. So let's follow the procedure. It's the stat button, and then we go to edit, okay? Now these already have our data for the previous problem where we used L1 and L2. You can go to use L3 and L4, but if that confuses you, you could clear L1 and L2. The drawback by doing what I'm doing right now, clearing L1 and L2, is that now the data is gone, so you can't go back and check your previous answer unless you retype everything. So I would, if you know how to go to L3 and L4, I would do that, and that might be a better idea. I don't do that because I don't want to add another layer of things you need to know. So what did we do? We pressed the stat button, and we got to edit, and now we cleared this, and now we're using the data. So the mass, we already did diagnostics on, remember a catalog, scroll down to diagnostics on and turn it on. You have to do that. You're required to do that. You won't get this answer for the second part if you don't do that. So diagnostics on. Now we're gonna put in the data, 4.5. For the mass, 5, 4, 3.5, 5.5, 5, 5, 4, 4, 6, 3.5, 5.5. Oops. And now I made an error. You do want to check if you made a mistake or not. So 5.5, 3.5, 6, 4, 4, 5, 5, 5.5, 3.5, 4, 5, 4.5. Good. You always want to check. It's just a quick thing. Quick check. Because this answer will come out wrong if you mistyped it and you won't know. Because there's no reason to know. And in fact, everything will change very little if you mistype something, unless you completely put a 55 instead of a 5. But even then, it doesn't change much. So now L2, 41, 40, 35, 38, 43, 44, 37, 39, 42, 44, 31, and 30. Okay, so 30, 31, 44, 42, 39, 37, 44, 43, 38, 35, 40, 41. All right, so now we have to quit and we have to get the linear regression equation. This does that for us. Stat, calc. Now it's linreg. AX plus B. I wish they put an M here instead of an A. I don't know why they don't. Linreg AX plus B. L1 is the first element. Okay, it's usually put as L1. L2 is the second element. Okay, notice it was mislabeled here. So I had to put it in. It's L1 in blue above the 1 button. So I pressed the blue second button and put L1. Okay, L2 frequency list. There is no frequency list. Store the equation. I like to store the equation. So what I do is vars, and this is where you store it. Go to y variables, function 1. You can store it as 6 or 7 or 3, whatever you want, because it's gonna be stored in the y equals section, okay? And then calculate. Okay? And here's the equation. Y equals ax plus b, where a is 1.97. So we have to round to the nearest 10th, so a is 1.917, 1.9. So let y be the height, so y is equal to 1.9, not 1.917, you'll lose points, x. If you have to pay attention to what it says, then plus b plus 29.79. The next number is a 9, so we have to round up to 7 to an 8, so 29.8 plus 29.8. Okay, so now state the value of the correlation coefficient to the nearest 10th and explain what it indicates. This is almost always strongly correlated. This is actually the first time in years that I've seen a low correlation coefficient. This is R. So let's see. R is equal to 0.3 to the nearest 7, 3. So R equals 0.3. So what does this mean? So it means, this is notes. So if R is between, so if 0.7 is less than the absolute value of R, including negative, R could be negative, and less than 1, less than or equal to 1, this is a strong correlation. Okay, then if 0.2 is less than or equal to absolute R is less than or equal to 0.7, okay, then this is a weak correlation. And then if 0 is less than or equal to absolute R is less than or equal to 0.2, this is usually no correlation. Okay? 1L. Okay, so what does that mean? It means that the data points are strongly related to each other, weakly related to each other, or not related to each other. So the fact that R is 0.3, it means that there's a weak correlation. So this means there is a weak correlation between the mass and height of, what are we relating mass and height of? Let's see, certain breeds of dogs. Dog breeds. Cool. Número 35, number 35. Miranda received a movie gift card for $100 to her local theater. Matinee tickets cost $7.50 each, and evening tickets cost $12.50 each. If X represents the number of matinee tickets she could purchase, and Y represents the number of evening tickets she could purchase, write an inequality that represents all the possible ways Miranda could spend her gift card on movie theater tickets. Then on the set of axes below, graph this inequality. They were nice enough to label it for us. And then what is the maximum number of matinee tickets Miranda could purchase with her gift card? So let's actually just go one piece at a time here. Miranda received a movie gift card for $100 to her local theater. Matinee tickets cost $7.50 each, and evening tickets cost $12.50 each. And if X represents the number of matinee tickets she could purchase, so X is equal to the number of matinee tickets she could purchase, okay? And Y represents the number of evening tickets she could purchase. So write an inequality that represents all the possible ways Miranda could spend her gift cards on movies at the theater. So it looks like she could buy a bunch of matinee tickets and a bunch of evening tickets, and that up until the point where her gift card runs out. We talked about above at a previous problem how a cost is related to the number of the same object that you buy. We talked about it how that if one ticket costs $7.50, 2 costs $15, 3 costs $22.50, and it gets harder and harder to get the final number because after a while adding up a number multiple times gets difficult. But we talked about that adding a number multiple times is where the multiplication operation originally came from. The reason we use the word times is because when we say like 750 times 8, we mean 750 plus 750 plus 750 added 8 times. So in this case, 750 is not added 8 times because 750 is the cost of a matinee ticket, and the number of matinee tickets we bought is unknown X value. It's an unknown variable X, which we inherited that name. So if we buy $7.50 tickets, $7.50 tickets X times, the cost is equal to, for the matinee tickets, it's $7.50X. You see, the cost for one ticket times the number of tickets. It's always the same. The same deal here. The evening tickets cost $12.50. So the cost for all the evening tickets, it's $12.50 times how many tickets we bought is Y. And now this cost has to be less than or equal to the amount of money that Miranda received. So less than or equal to 100. Okay? All right, so how do we graph this? There's, do I want to teach you a new way of, I think I do want to teach you a new way of graphing this, because the thing is that a lot of times we're used to graphing the y equals mx plus b way of graphing an equation, and then we have an equation that's not written in y equals mx plus b form. And then we get confused, especially if we're the kind of student who struggles with the y equals mx plus b form. So if you know how to do y equals mx plus b, go ahead and do y equals mx plus b. I'm going to actually show you how to do this a different way, because this isn't actually what's called a standard form. Why it's called standard form is a little esoteric. It has to do with quadratic equations, and these are not quadratic at all. But we're going to use the method of noting that if x is 0, the only term here is y. So the y-intercept is equal to 100 over the coefficient of y is 1250. And we can use the calculator to get this. 100 divided by 1250 is actually 8. Okay, so the y-intercept is 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, the x-intercept is equal to, this is in the case where y equals, on the x-axis y equals 0. So if y equals 0, this is 0, so 750x is less than or equal to 100, so we actually get 100 divided by the coefficient of x is 750. And I do need a calculator for this one. 100. It is a decimal, so 750. Okay, and it's 13.33. So what do we do here? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.33. So it's 13 1/3. Okay. Now notice I didn't label the numbers as 1, 2, 3, 4, 5, 6, 7, 8. And I didn't label the numbers here. If you count up by 1, you don't have to. If you count up by anything other than 1, you do have to. Okay, so I've got the line here using the software on my side. You have to use a straight edge again because the line is a straight line. If you don't use a straight edge, you get the question wrong. Now you might also notice that this is an inequality, right? So how do I decide if I should make an inequality with a dotted line or a solid line? If you draw it with a solid line, if equality is valid, so if it's less than or equal to or greater than or equal to, and you draw it with a dotted line if the inequality is a less than or a greater than inequality. This is a less than or equal to inequality, so I know it's a solid line. So now how do I decide if I'm going to shade on bottom or above? So this, the way we can do this is by testing a point. We could the way we test a point is by saying choosing a point below or above and seeing if it's a valid point in this inequality. So I'm going to choose a point if we buy one matinee ticket and one evening ticket. So if we buy a matinee ticket and an evening ticket, that's 1 and 1. Y is 1, X is 1. So 750 plus 1250 is $19.100 is $20, and which is less than or equal to 100. This point is in the solution of the inequality. So every point below the graph is in the solution of the inequality. So we actually shade below. Okay. Now I don't know, because the grading method is not released yet, so I don't know if you graph the line perfectly, but if you didn't shade here, if it's worth a point or 2 points. But this is a complete graph here. So notice nothing is shaded above, and notice I don't go to the left of the graph or below the graph, okay? So now we go to the next part. What is the maximum number of matinee tickets Miranda could purchase with her gift card? So, and explain your reasoning. And so now we have to use words, okay? Words. Words are required. So let's give words. So we maximize matinee tickets by, well, if we buy any evening tickets, then we're spending money on that, so which leaves less money to buy matinee tickets. So we maximize the matinee tickets by a number of matinee tickets, okay? By buying 0 evening tickets. Okay. Okay, so let's go back to the inequality. So 750x plus 1250y is less than or equal to 100. So 750x plus 1250 y is less than or equal to 100. We let y equal 0, so 750x plus 1250 times 0 is less than or equal to 100. So this is 0. So 750x is less than or equal to 100. Divide by 750. Divide by 750. And we get that x is less than or equal to, and we did this calculation before, 13.3 repeating, okay? 3 repeating. If we stop here, we don't get the point that we wanted because you can't buy a third of a matinee ticket. We can't buy 0.3 repeating of a matinee ticket, so we can buy 13 tickets. And a very common strategy for the test is if like this number is bigger than 5, then you would think you'd round up. But then if you don't have the money to buy like 0.8 of a ticket either, you still can't buy that ticket. So it's this number. So we can buy 13 matinee tickets. I hope this video is helping you like I think it is. If it is, click the subscribe button. And also, I again invite you to click on the review packets that I created for you. They really are that good. And they're really at an affordable price. And then on top of that, I've lowered the price by 20% to thank you for watching this video. Let's go on to the next problem. Número 36. Second to last problem. One spring day, Elroy noted the time of day and the temperature in degrees Fahrenheit. His findings are stated below. At 6 a.m., the temperature was 50 degrees. For the next 4 hours, the temperature rose 3 degrees per hour. The next 6 hours, it rose 2 degrees per hour. The temperature then stayed steady until 6 p.m. From there, for the next 2 hours, the temperature dropped 1 degree per hour. The temperature then dropped steadily until the temperature was 56 degrees Fahrenheit at midnight. On the set of axes below, graph Elroy's data. There's a lot of little mini pitfalls here, but I don't expect you to keep all of that extra info in mind. They don't expect you to do that either. The way to do this problem is not to keep all that crazy stuff in mind. It's there so you can refer to it. So let's look at the graph. Don't forget to subscribe. On the set of axes below, graph Elroy's data. The temperature, I see it goes up from 50 to 60 in 5 boxes, so it's skip counting, and good for them for labeling the graph for us. Then, so it's skip counting the temperature by 2 degrees each time, and the temperature looks like it's not skip counting 6 a.m., 7 a.m., 8, 9 a.m., 10, 11. So it's going by 1 hour up. And so now we carefully graph the details using dots, and then connect what we should connect with straight lines, and connect what we should connect with curved lines. Fair warning, they don't want you to assume that somehow the curves curve in some weird way just because. If they don't give us information of the time in between, then we should assume that the curve is straight linear for the pieces. So let's see, at 6 a.m. the temperature was 50 degrees. Let's go for the red pen. 6 a.m. the temperature was 50 degrees, okay? Keeping in mind the boxes to the right count per hour, upward count 2 degrees. So then for the next 4 hours, the temperature rose 3 degrees. For the next 4 hours, so until 10 o'clock, the temperature rose 3 degrees per hour. So 7 a.m. going up 3 degrees. Remember, this is skip counting by 2, so 3 is not here, it's here. Okay, 8 o'clock, 3 degrees more. That's 2 hours, not 3, just because there's 3 dots, it's 2 hours. Remember, an hour is a gap. Hour is a gap, not a dot. 9 o'clock, 3 more degrees. 10 o'clock, 3 more degrees, okay? Now, the next 6 hours, it rose 2 degrees per hour. So from 10 o'clock plus 4 hours is 4 o'clock p.m. Plus 6 hours is 4 o'clock p.m. So it rose 2 degrees per hour. So now we're gonna go up by 2 degrees each hour. Remember the boxes are skip counting by 2. So 1 hour, 2 hours, 2 hours, 2 degrees, 3rd hour, 2 degrees, 4th hour, 2 degrees, 5th hour, 2 degrees, and 6th hour, 2 degrees. And let's just make sure that we skip counted correctly. This is 4 p.m. then that's the last dot. Then the temperature stayed steady until 6 p.m. 6 p.m. is 2 hours later. So stayed steady. Cool. Then for the next 2 hours, so until 8 p.m., the temperature dropped by 1 degree per hour. Remember, we'll skip counting by 2, so half a box is 1. There, half a box is 1, half a box is 1. And then the temperature then dropped steadily until the temperature was 56 degrees at midnight. So right now we're at 72 degrees. And we're gonna go down to 56 degrees at midnight. This is the only point where we suddenly have to do a little bit of algebra, okay? So we have to do the rate of change from 8 p.m. to midnight. So let's see, delta capital T for temperature over delta little t. Why is my printer making noises? So delta T over delta T is final minus initial, so 56 minus 72, and divided by the time, 12 minus 8. So this is equal to 56 minus 72. If you're not comfortable with negative numbers, you could use a calculator, but you can also count up and then negate it. So negative 56 to 60 is 4, to 70 is 14, to 72 is 16, and divided by 12 minus 8 is 4. So this is a change of negative 4 degrees per hour. So we're going to drop by 4 degrees, and let's use it as a check. We should definitely end up exactly here by dropping 4 degrees per hour. So let's see, 4 degrees down, 1 hour. This is looking good already. 4 degrees down, 1 hour. 4 degrees down, 1 hour. And 4 degrees down, 1 hour. Perfect. And then we stop. Okay, so now, do we connect these with straight lines or curves? We connect them with straight lines because there is no information that says, let me just go in blue for a second. There is no information that says that this thing is like some weird curvy thing. You see how I'm drawing it kind of curvy? There's no information that says that that's the case. So in fact, we do need to use a straight edge in this problem. So instead of wrestling with the software, I'm gonna skip right to the point where we have the straight lines, and here they are. So the straight lines have to be drawn with a straight edge. The straight lines go from here to here, stops, another straight line 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 from here to here. Okay, so we've graphed the data. Cool. So let's keep going. Now, to state the entire interval for which the temperature was increasing. So I just have to state it. It was increasing from 6 a.m. all the way up to 74 degrees at 4 p.m. Okay, so from 6 a.m. to 4 p.m. And that's it. No full sentences. You don't need them. The temperature was increasing from 6 a.m. to 4 p.m. If you want a full sentence, you don't need it. Good. So now determine the average rate of change in degrees per hour from 6 p.m. to midnight. 6 p.m. to midnight. So the average rate of change, this is an important topic, and they do ask this question on multiple choice, part 2s, and on the SATs and ACTs. So average rate of change, rate of change is equal to T final minus T initial over time final minus time initial, okay? So T final, temperature final is, and notice the ordering of that it's always that. Don't like change it just because you get a negative number. The temperature is dropping. The average rate of change is negative, right? So the temperature final is 56 degrees. Is 56 degrees minus, it's the same calculation that we did before, but with slightly different numbers. The top temperature was 74 degrees, okay? 74. And then the time final was 12. So, and then minus the 6 p.m. So this is equal to 56 minus 74, which again, you should use a calculator if you're not comfortable with the negative number. But 56 minus 74, if I count from 56 to 76, I get 20. Go down, I get 18, so negative 18. Divided by 12 minus 6 is 6, which is equal to negative 3 degrees per hour. I'm going to change my answer as a hint to you if you're taking the Regents. If they give you the units, okay? Units given, then don't give units. Do not, okay? This is a pro tip. Do not give units. I gave them, and I gave them correctly. So I'm gonna cross them out. 3 degrees, -3. Why? If they give you the units, they're already stated. You don't have to give them. If they didn't state the units, or if they ask you for the units, you do have to state them. But notice they gave us the units. So now why do I say don't state them? -3 is a correct answer. Why? Because the units are degrees per hour, because they said so. However, if I give the units 3 degrees per hour, I'm not wrong. On the other side of it, if I make a mistake, which happens all over the Regents, and I'm talking about, I've graded so many of these, and you get the units wrong, you lose a point. So there is no point in ever giving the units in Algebra 1 Regents unless it's clear that they want you to give them. And how do you know if they want you to give them? If they say so. So they say, give me the units. They didn't say that here, so I'm not giving them. Done. -3 is the answer. That's a pro tip. Your teacher might not like me when I say that. I'm a teacher too, though. Trust me. And we finally made it to the last question of this test. Number 37. If you appreciate the work that I've done for you, if you even remotely like the quality of work that I've done, please hit the like button so that other students can see it. Please click the subscribe button because you're gonna get other videos in the higher tests. I'm making them as we go. And of course, like I said, check out the stuff that I have. Even if you don't plan on buying it, just go check it out. See if it might be worth it for you. You might be surprised. The price is really not that high. I'm not charging like $30 for that one that one review packet. It's very small. As I go in the future and I start creating a actual class, that might be a little bit more expensive. But this is a prelim. This is just a baseline. It's a midterm. It's a final, and in a few days. Because I'm handing it to my students in about February 15th, I'll have another packet and it's going to be there too. So if it's after February 15th, it's going to be there too. Check those out, and love the t-shirt. Pi Day 3.14, March 14th, it's coming up. Definitely check out the t-shirt too. Let's go for the prize of this test. Number 37, it's 6 points. Okay? 6 points is a lot. Out of 86 points. In fact, on this Regents, if you get full credit on this question, which only requires, the test only requires 27 points. So you're actually, it's a little over 20% of the points that you need to pass the test if you get full credit on this question. Believe it or not, 20% of, more than 20% of the way towards getting a full a passing grade, about 22-23%. So let's do Número 37, number 37. Recreation Center ordered a total of 15 tricycles and bicycles from a sporting goods store. So total of 15 tricycles and bicycles. The number of wheels for all the tricycles and bicycles totaled 38. Write a linear system of equations that models this scenario where T represents the number of tricycles and B represents the number of bicycles ordered. Okay, I know this question is tough for a lot of students, right? But let's go convert the questions, the words into equations, okay? And I'm not going to continue reading with the rest of it. Let's just focus on this one part because this is actually an important skill to have just in general, but also for this test. So a recreation center, and they love asking this question, a recreation center ordered a total of 15 tricycles and bicycles. So the total number of combined tricycles and bicycles is equal to 15. So number of trikes plus number of bikes equals 15. And then we have it, the words converted into an equation. T is the number of tricycles, T plus the number of bikes, B, equals 15. And we got a point, right? The next part, so let me move this over, something I can do. Oop, apparently I can't do. I thought I could do it here. No, I can't do it. So I'm gonna go over here, and I'm gonna talk about the wheels. Okay, this is the part that could cause a little bit difficulty. The total number of wheels is equal to 38. So this is how it is. The number of trike wheels plus the number of bike wheels equals 38. Now this might seem tough, but if you go back to what I've been talking about throughout this video, it's that if you actually think about what multiplication is a repeated addition. You can actually get an expression for this quantity. Remember, if one tricycle has 3 wheels, oh, that's something they do expect you to know, that a tricycle has 3 wheels and a bicycle has 2 wheels. So the prefix tri is 3, the prefix bi is 2. Okay, so one tricycle has 3 wheels, 2 tricycle has 6, 3 tricycle has 9, 4 tricycle has 12. Oh wait, but if I ask you for 30 tricycles, what would you do? You'd add 3 30 times? No, 3 30 times, 3 30 times, 3 times 30. So you take the number of wheels in one tricycle times the number of tricycles, that's it. So 3 times the number of tricycles is t, plus the same deal with the bikes, 2 wheels per bicycle times the number of bicycles that you have. So 2 times the number of bicycles, that's a b. Okay, let's make that clear. B is equal to 38. And those are our equations. Let me write them a little bit neater here. So t plus b equals 15, and 3t plus 2b equals 38. Nice, right? And then on the set, let's go to the graph. On the set of axes below, graph this system of equations. You can turn it into so b is the y-axis, and what you can do is, and I'll show you both ways. Let me go in blue. Okay, so you could turn it into a y equals mx plus b type of situation. Solve for b, because b is the y-axis. So b equals 15, mx plus b, so negative t plus 15. I subtracted t from both sides. And then I have a slope of -1 and a y-intercept of 15. Bam. Slope of -1, and I get to here. Okay, there. Okay, so I keep going, and I don't need you to see me wrestling with the software, so I'm just gonna draw this, and there's the straight line. You do have to do this with the straight edge. So the second one, I'm going to do it the other way, because I know a lot of students mess up the y-intercept form. Instead, I'm going to do it the other way, because this is the standard form. The standard form is, let's switch back to red. The standard form, there's a nice easy way of getting the intercepts. Let one value be 0. So on the y-intercept, on the b-intercept, t is 0. So 2b equals 38, so b-intercept. 2b equals 38, or should I say, let's make it clear. 3 times 0 plus 2b equals 38. This is a 0, so this is gone. So divide by 2, and this is gone. I don't need to divide this by 2 because it's not there, right? 0 is plus 2b is 2b. So b is equal to 19. Okay, so the b-axis is 19. The b-intercept is 19, and also the t-intercept. Okay, so I got 3t, so when on the t-intercept, b is equal to 0, so 3t plus 2 times 0 is 38. So 3t equals 38. That's a 0, right? So divide by 3, and I got t is equal to 38 over 3 is 13 minus a third, so 12.6 repeating. Okay, 12.6 repeating. Good. Let's confirm that with the calculator. I don't want to make problem 37 the point where I mess up for you guys, but I do know the answer. So 38, because 39 divided by 3 is 13, right? So there it is, 12.6 repeating. So that's the t-intercept. And now I'm going to connect this with a line, and there it is. Okay, so do you have to connect this one with a straight edge also? Yes, you do. But here it is. Now, the next step. Based on your graph in the scenario, could the recreation center have ordered 10 tricycles? Explain your reasoning. So let's see, 10 tricycles. If we go to 10 tricycles, that means we go up. Let's see. So the number of wheels total 38. Can they have ordered 10? So here's the thing. This is not even an inequality question, so it's not below. They can ask an inequality question below, so they can graph this region, but they're not asking an inequality. They're saying that it's a true equality. So this is the exact scenario that corresponds to this problem. Now I see that the problem is kind of not on a corner. It looks like it kind of is on a corner, like maybe 8 tricycles and 7 bicycles. And what happens when we draw with a pencil, we might be a little bit inaccurate with our graph. But if we look down here, let's see, down, the slope is negative 3 over 2, so 3 and 2 and 3 and 2 and 3 and 2. So this graph does cross here. Okay, so this is the correct corner, 7 and 8, so 8 comma 7. So that is the only point. This is the point, the only point. So the question is, could the recreation center have ordered 10 bicycles? Explain your reasoning. So the answer is no, because if they order 10 tricycles, so this 10 is not on that point. It's 8 in fact. So and it says based on the graph. Okay, so we have to use the graph. I was about to give an explanation that involved the algebra. Like if they ordered 10 tricycles, then they ordered 5 bicycles. Then the number of wheels is 10 times 3 is 30, plus 5 times 2 is 10 is 40. But that's not a valid explanation because they said based on the graph. If they ordered 10 tricycles, then they ordered 5 bicycles. Okay? Okay, I can't spell bicycles. Bicycles, right? But the graphs intersect at the point 8 comma 7, which means they ordered 8 tricycles and 7 bicycles. And that's the full explanation. There's a lot of explanations that say why they couldn't have ordered 10 tricycles, but again, they did insist that we do the graph. I hope that this video was as rewarding for you as it was fun for me to make. I really appreciate you watching this video. Listen, and I know you can do it. I fully believe in your abilities. If you appreciate the video that we created, definitely hit the like button, click the subscribe button, because we have way more videos coming. We have way more videos in the past, so you know they're going to keep coming. And check out the review packets that we have right on bottom, check out the t-shirt. I think it's a really awesome t-shirt. This one t-shirt has gotten more compliments from friends and family than any t-shirt that I've ever worn, that I've ever created myself. So definitely check it out. Thanks for watching. Stay tuned for the next video coming up.